Okay, so the question says there's a data given, and in that data, let us read following is the record of the performance of a hockey team for the 7 tournaments played in 1 year. Okay, there's a hockey team that has played certain number of tournaments, and this is the record available. The record says for the first tournament there were 5 matches won by the team and 3 matches were lost. So in all there were 8 matches. Second tournament, there were 4 matches won by team and 4 matches were lost, and there were 16 such tournaments. So on, this is the record given of the all 7 tournaments. Now the question asked is how many matches did the team win during the entire year? So clearly what we are supposed to do, clearly we are supposed to add this particular column and we're going to get the total number of wins by the by the team, by the hockey team. So if we all add this number 5 plus 4, 9 plus 5, 14 plus 6, 20 plus 4, 24 plus 3, 27 plus 2, 29. So that is the total of all these, that is 29, which is available in option number B becomes the right answer. Now, in the same data, he's saying, what is he asking? What percent of the matches did the team win? What percentage of the matches did the team win? For that, we need to do what? Percentage win. If we want to calculate percentage win, then the formula says we have to find out the total number of wins divided by total number of matches. Okay, total number of wins divided by total number of matches multiplied by 100%. This is how the percentage win can be calculated. So just in the in the earlier question, we calculated the total number of wins. The total number of wins by the team is 29 divided by how many were the total number of matches. For that, we need to add these number. Okay, so if we keep on adding this number, okay, we're going to get the total number of matches being played, and that is available here 50. Okay, so total number of matches played are 50. So 29 by 50 into 100%. That's what we are supposed to calculate. And obviously this will be sum in decimal, so we'll have to approximate the data. So if we calculate exactly, this is coming out to be exactly as 58%. Okay, 29 by 50 into 100% gives you 58%. That is the right answer available in option number C. Now he's saying for the same data, he's saying according to the chart, which tournament was the worst for the team? Okay, which tournament was the worst out of all of them? So the tournament, that particular tournament will be worst, where the number of matches lost will be maximum and the number of matches won will be minimum. So let us find out. In the first tournament, 5 won and 3 lost. So this is fine. 4-4. So this is equal. 5 win, 2 loss. This is fine. 6 win, 3 loss. This is also fine. Winning is more. 4 win, 2 loss. This is fine. Winning is more. 3 win, 3 loss. This is fine. In the 7 tournament, he is winning just 2 matches and losing 4 matches out of them. So obviously the losing number is more than the winning number. So obviously this must be the tournament that would have been worst for the team. So let us mark option number 7 is the right answer. Now, for the same data, he's saying in the next question is which tournament was the best tournament for the team? So in that particular tournament where the matches won would have been highest in comparison to the matches lost, that would have been the best tournament for the team. If we see at this 5-3, it could be considered as one of the good tournaments. 5-2 also can be considered as a good tournament. 6-3 also a good tournament. 4-2 can be equal. 3-3 is also almost equal. So out of 5-3, 5-2, and 6-3, we have to find out which tournament becomes the best for the team. So for that, we can find out the winning percentage. So for the first tournament, the winning percentage becomes like 5 by 8 into 100%. Okay, this is the winning percentage. For the third tournament rather that we have selected, the winning percentage is 5 by 7. For the third tournament, the winning percentage is 5 by 7. Okay, and in the fourth tournament the winning percentage becomes 6 out of 3. Okay, 6 out of 9 rather. Okay, so clearly if we look at this 5 by 8, 5 by 7 and 6 by 9, so we can easily find out that this third tournament becomes the highest winning tournament. Okay, this third tournament becomes the highest winning tournament for the team. So the third one is the right answer, that is option number B. Okay, for the same data, he's asking if there are 50 more matches to be played in the year, how many more matches must the team win to end up winning 70% of the matches? So there are 50 more matches being played. So how we can solve this? So how many matches have been played by the team now? Till now are 50. He's saying 50 more matches are being played. So how many total matches will be there then? In that case, there will be total 100 matches. What does he want from us? He wants that when the 100 matches would have been played in the future, then out of those 100, 70% should have been won by the team already. So if 70% would have been won by the team, so what is the 70% of 100? Is obviously 70 itself. So after the 100 matches being played, there should be 70 wins scored for the team. Let us find out what are the initial wins. How many matches have been won by the team till the 50 matches have been completed. So we just calculated there have been 29 wins for the team out of 50, and he wants the 70 wins out of 100. So obviously, how many more matches he will have to win to score 70 out of 100? That will be simply 70 minus 29, and 70 minus 29 gives you 41. So clearly he will have to win 41. The team will have to win 41 more matches so that its total becomes 70, and the percentage then becomes 70% of the total matches played at that point of time. So that becomes the right answer. 41 is the right answer, option C. Now we have a different data this way. What is the data all about? Let's study the data first. The data says number of different classes of vehicles sold in the country over the years. Okay, so there is country wise the data is given 1990. The data is said 990. Then there is class 1, class 2, 92, 94. So it's 5 years data over there. Class 1, class 2nd, class 3rd, class 4, class 2. Class wise, the total vehicle sold has been displayed. The sale of the vehicle class wise and year wise, the sale has been displayed. Let us see the question. Percentage increase in sales in 1993 over the previous year was maximum for which class of vehicle? So the question's language says, for which of the class out of 1 to 5 percentage increase in the sale of 93? So we have just to calculate for the value for the data of 93, that for which class percentage win in the sales of 93 over the previous year was maximum. So we have to calculate for each class the data in the reference of the previous year value like this, in the reference of previous year value like this. For example, if you want to calculate for class number 1, what is the percentage increase? Okay, if you want to calculate the percentage increase for class 1 data, then for percentage increase, what we do, see 1993 the value is 81. So 81 minus, in 1992 in the previous year the value is 72. So that is the difference, that is the actual increase. In terms of percentage, if we have to calculate, we'll have to divide this increase by the base price, that is of 1992, that is 72, into 100%. So this is how we can calculate the increase percent of the first class. Okay, so if we calculate this further, this comes out to be 9 by 72 into 100%, which is nothing but 100 by 8%, and that is exactly 12.5%. So this is how we can calculate for class 1. We have to calculate this data for each class and then compare that for which particular class the percentage increase was maximum. So if we calculate for class 2nd, we have to do 93 minus 79 divided by 79 into 100%. Okay, and for class 3rd, what we can do is obviously 280 minus 248 divided by 248 into 100%. Okay, for class 4, what we can do is 241 minus 210 divided by 210 into 100%. For class number 5, what we can do is 411 minus 404 divided by 404 into 100%. So these are the different data that have been calculated. So after calculating these values, we can write down the values. So this value is coming out to be 17.7%. For class 3rd, it is coming out to be 12.9% precisely. For class 4, it is coming out to be 14.7% precisely. And for the class number 5, the last class, it is coming out to be simply 1.7%. So if we compare these datas all together, then we can obviously find out the highest percentage increase, which is available in class number 2nd, that is 17.7. So that becomes the right answer. Class number 2nd is the right answer. Now, for the same data, we have to calculate a different thing. What is the different thing? In which year was the number of class 5 vehicles sold the highest percentage uh, sold the highest percent of the total number of vehicles sold during the year? So what we have to do, in which year number of class 5 vehicles? So we have to just calculate the data for class 5 vehicle. Okay, for, in which year the number of class 5 vehicles sold the highest percentage of the total number of vehicles sold during that year? So for the case of 1990, what we can do, the number of vehicles sold of the class 5 is 340 as given here. For the year 1990, the number of vehicles sold for class 5 class is 340. So that becomes the numerator, divided by, he's saying, with number of class vehicles sold, highest percent of the highest percent of the total number of vehicles sold during that year. So we have to find out what is the total number of vehicles sold in the year 1990. So we have to add this way, add the row of 1990 all together. Okay, so we have to add the row of 1990 all together. So clearly we'll have to add these number 26 plus 64 plus 233 plus 153 plus 340, and we'll have to write that total here. If you do it, it becomes like 6 plus 4 10 plus 2 12 plus 3 15 plus 0 15 plus 0 is going to be 5, and the carry will be 1 obviously. 1 plus 2 3 plus 6 9 plus 3 12 plus 5 15 plus 4 19, that is 9 here. 1 is the carry. 1 plus 2 3 plus 1 4 plus 3 7. So 340 by 795 into 100%. So this is the data for the year 1990. Total number of vehicles sold in class 5 divided by total number of vehicles sold in the entire year. Okay, so this is the data. Similarly, we can formulate the data for our 1991 also. That will be 336, that is the number of vehicles sold of class 5, divided by total number of vehicles of the year 1991, total vehicles of 1991, and multiplied by 100%, and so on. We have to calculate for each year, 92, 93, 94, such things like that. And after calculating that, obviously we can know the percentage value. So let us find out. So for the 1919 case, it is coming out to be 41.7%. For 91, it is coming out to be 39.3%. For 1992, the value is coming out to be 39.8%. For the year 1993, the value is coming out to be 37.1%. For the year 1994, the value is coming out to be 38.04%. So clearly, if we compare which particular year has got the highest percentage, so that is obviously year number 1990. So that becomes the right answer, year number 1990. Now, for the same data, is asking number of class 1 vehicles sold in 1993 was approximately what percent of the total number of vehicles sold in 1992. So data of 1993 is what percent of data of 1992. That's what we are supposed to find out, and this is to be done for only class 1. So let us see class 1 1993 number. So class 1 1993 number is 81. So we have to find out 81 is what percent of the next number we have to find out is vehicles sold in 1992. For the same class 1 1992, the data is 72. So we have to find out 81 is what percent of 72. Number of class vehicles sold was approximately what percent of total number of vehicles sold in 1992. We have to do the total of 1992. So we have to add all these numbers. It's not just 72, it has to be a sum of all those. So that is 72 plus 79 plus 248 plus 210 plus 404. Okay, so this is what we have to find out. 81 is what percent of the total of all 1992. So it becomes like 81 is the total of, so 81 is what percent of, if we do this total is coming out to be 1013. So 81 is what percent of 1013. So for that we can use this thing, 81 out of 1013 multiplied by 100%. This is how we can find out what percent it is. Okay, if we calculate this further, this is coming out to be 8%. So that becomes the right answer, 8%. Okay, that is available as option number A. Now, for the same data is asking, if the same percentage increase in the number of class 1 vehicle in 1994 over 1993 is expected in 1995 also, approximately how many vehicles will be sold in 1995? So clearly he's saying whatever has been the percentage increase of class 1 vehicle from 1993 to 1994. Okay, so what is the increase first? Let us see the increase. In 1993, class 1 vehicle in 1993, the value is class 1 vehicle, the 1993, the value is 81. Okay, same class 1 vehicle in the year 1994, the value is 107. So he's saying whatever percentage increase has happened here, that's what is expected in the next question or in the next year also. So how many vehicles more should be sold so that particular percentage increase is met? So first of all, we'll find out the percentage increase from 1993 to 1994. So percentage increase is obviously the increased value minus the older value divided by the older value itself into 100%. This is how the percentage increase is calculated. And if we calculate this, this is coming out to be precisely 19.75% approximately. Okay. Now he's saying the same percentage is increase is expected when you grow from 94 to 95. Okay. So in 94, the value is 107. In 95, he's wanting to find out that value. Okay. So that the percentage increase of 19.75% is achieved. That means the value in 1995 will be 19.75% more than the value in 1994. In the 1995, the value should be 19.75% more than the value in the 1994, that is 107. Okay, so we are clearly supposed to find out 94, rather 107 plus 19.75% of 107. This is what we are supposed to find out. If we do it like this will be 107 plus 19.75 divided by 107 into 100, rather 107 divided by 100. And if we solve this further, this is coming out to be 128 approximately. Okay, if we solve this further, this is coming out to be approximately 128. So that is available in option number B. So 128 vehicles will be total sold. Now, for the same data is asking, in which of the following years was the number of class second vehicles sold approximately 25% of the number of class 5 vehicles sold? Okay. In which year this is happening? For class second only. So we have to just look for the class second data. In which year this is happening, that vehicles sold approximately 25% of the number of vehicle class 5. Okay. So we have to compare class second and class 5, and we have to find out in which year the value of class second is just 25% of value of class 5. So we have to check like whether 64 is 25% of 340, whether 60 is 25% of 336, whether 79 is 25% of 404, and let's keep on checking. For whichever year we find out the same, we can declare that as the right answer. Okay. So if we find out for the year 1990, then uh, then we can find out between 64 and 340. So we have to compare. So 64 is what percent of 340? This is how we can find out. So this is coming out to be exactly 60%. So that is not the right answer, because we are supposed to find out 25%. Okay, for the year 1991, we are supposed to find out 60 is what percent of 336 into 100%. If we calculate this further, this is coming out to be for the year 1991, this is coming out to be 60. Okay, this is again coming out to be 60%. Okay, 1990 equal to 60, rather it is coming out to be 17.8%. For the first one, it was coming out to be 18%. Okay, now for the year, same in the same way, for the year 1992, 79 is what percent of 404? We have to find out 79 is what percent of 404. So we can do it like this. And if we solve this further, this is coming out to exactly 19.5%. For the year 1993, we are supposed to find out uh, 93 is what percent for the year 1990. 93 is what percent of 2, rather 411 is what percent of 411 into 100%. This is how we are supposed to find out. And this is value is exactly coming out to be 22.5%. And for the last year 1994, we have to find out uh, 112. 112 is what percent of your 442, okay, into 100%, and this is coming out to be, and this value is exactly coming out to be, precisely coming out to be 25%. 112 is what percent of 442, so it is 448 would have been the right value, so it is close to 25%. So this becomes the right answer. For 1994, we are getting the answer as 25%. Okay, now let's go for the next one. There is a data given. We have to see the data first. Production of different types of watches, figure in thousands. So every value is in 1,000 units. Okay, so production of different types of watches, watch type A, watch type B, C, D, E, F, and so on. And this is given yearly for the year 95, 96, 97, and till 2000 it is given. So year-wise, different types of watches have been produced, and that particular data is given to us. The question says, in 1998, production of which type of watch was about 40% of the production of type A in the preceding year? So what they're asking in 1998, so we have to see the 1998 data. In this particular year, they are asking production of which type of watch was about 40% of the production of type A in the previous year. So for this thing, we have to check for production of within reference to the production of type A in the preceding year. So we have to compare this with the production of type A in the preceding year. So in 1998, production of which type of watch was about 40% of the production of type A in the preceding. So production of type A in the preceding year is 180. So we have to compare all the values in reference to 180 only. Okay. To compare all the values in terms of 180 only and find out the percentage value. Okay. So first for the case of type A, we can check. So in 1998, type A has got a value of 175 and 40% of the production. So we have to find this percentage with 97. Preceding year is 97 and in the preceding year the value is 180. So 175 divided by 180 into 100%, this will not be equal to 40%. Clearly, because this is very much close to 180, so it cannot be 40% obviously. Now if we compare for B, so 1998 B value is 74 divided by 180, because we have to compare it with 180 only. 74 divided by 180 into 100. If we do like this, then this is, yes, this is coming out to be somewhat close to 40%, approximately close to 40%, because 72 would have been exact 40% and we are getting 74%, 74. So yes, this is approximately close to 40% only. So for type B, the things are being justified. So that is the answer, option number B, type B. Now, in this question, the data is same. What is the approximate percentage increase in production of type B watch from 95 to 96? What is the approximate percentage increase in production of type B watch from 95 to 96? So we have just to see type B watch and we have to find out the percentage increase from 95 to 96. So we have to just compare what is the approximate percentage increase in production of type B watch from 95 to 96. So 95 the value is 80, 96 the value is 85. So we have to find out the percentage increase when the value increase from 85 to 80. So for that we find out the actual increase first, 85 minus 80 divided by the older value, that is 80, into 100%. This is the percentage increase from 80 to 85. If we solve this further, this becomes like 5 by 80 into 100%, and that is nothing but 16 times. So it has to be 100 by 16, okay, which is nothing but 50 by, rather we can cut it by 4, so 25 by 4. So 25 by 4 is precisely 6.25%. Okay, so we can give the approximate answer. So exact value is not there, but 6% we can claim it as. So the right answer becomes option number B, 6%. Now, there is a value there, the data is still there, and we have to find out the different thing. In which year the production of type F watch was 8% of its total production? For which particular year? So we have to check it the year wise. For which particular year type F? So we have to just check for the type F. For which particular type F was 8% of total production. So we have to do the total of all the years together also. Okay. In which year the production of type F was, in which year the production of type F was the 8% of the total production. This is what we have to find out. So we have to obviously add all of them together. Okay, in which year the production of type F was 8% of its 8% of the total production. So let us do it year wise for type F. In which year we have to find out? So let us find out the data for 1995. Okay, 1995. What is the value of the watch F sold? Type of F sold is obviously 70, and we have to find out this as percentage value and compare that. So for this particular thing, 70 divided by, we have to do the sum here, sum of 138. So we are, because we are doing it for 1995, so we have to add it also, because he has said was 8% of the total production. So we have to add those values. It's 138 plus 80 plus 120 plus 75 plus 80 plus 70. Okay, it's about this and into 100%. And this we have to check for whether this becomes equal to 8% or not. So if we do it for 1995, this value is coming out to be, this total is coming out to be 500. So it's become like 70 by 500 into 100%. Okay, which is nothing but exactly 14%. Okay, if we do it for 1996, then we can do it the same way. In the 1996, the value is now 40, so it has to be 40 divided by sum of all the values of 1996. If we do this sum, this exact sum is coming out to be equal to again 500 by chance and into 100% that we have to do. If we solve it further, this becomes like 40 by 5. That is nothing but 8%. That's what we were interested in. For which particular year the production has to become 8%, and this is happening for the year 1996 itself. So that becomes the right answer for us. Now, in the next question, we have the same data is presented. We have to solve the question. Production of which type of watch together in 96 and 1998 is equal to the production of type B in 1999. Let us see the production of type B in 1999 first. So this is the 1999 data. Production of type B in 1999 is 120. So we have to match the total of 120, okay, with production of which type of watch together in 96 and 1998. So sum of which type of watches in 96 and 98 should be equal to 120. That's what we have to check for. Let us see. Okay, 1996 and 1998. 1996, the value of 1996 we have to add, and 1998 for each watch we have to, for each type of watch we have to do. Okay, for type A watch, 1996 value is 160 and 1998 value is 175. Clearly the total of 160 and 175 will be more than 120, so this is not the right one. For B, it has to be 85 plus 74. 85 plus 74 is obviously somewhat close to 159, so that is not the right answer. Also 80 plus 95, this is somewhat around 175, so this is also not the right answer. 85 plus 102 becomes 187. So that is also not the right answer. Okay. It has to be, then we have to see consecutively. Then 76 plus 90, 76 plus 90 is 166. That is also not 120. Then 40 plus 80, 40 plus 80. Yes, that becomes 180. 40 plus 80 is becoming exactly 120. So obviously for the year, for the type F, this is happening that the sum is becoming equal to 120. So right answer should be type F. But let us see the option. The type F is not available in the option, so we'll hit the answer as none of these, and that is the right answer. Okay, so for the same data, the question is production of which type has increased consistently over the year. So for this, we just have to check the table. For which particular type, there is a continuous increase. So let us see for A has become 138 to 160, A 180. Here there is a decrease from, so A is out. B, is it continuous increase? 80 to 85, fine. 85 to 78, so it is out also. Consistently, it has to increase. Type C, 120 to 180. So in beginning itself, there is a drop. So that is also cancelled. For D, 75 to 85 to 90 to 102, 400. Yes, this is the type where everything is consistently increasing. So type D becomes the right answer for us. And that is the right answer also. Okay, so the question says there's a data given. We have to read the data first. He's saying subscription to different schemes of mutual fund company over the month in the year 98, 99. All the values are in rupees in crores. Okay, so let us see what is given for month from starting from September to February. Which all subscription of different schemes have been done? So scheme V, scheme W, X, Y, Z, and so on. And there the totals also have been done for us. Okay, total of all the schemes from V to Z in September has been done for us here, and like that. Okay, so total is also done. Okay, so let us find out what he's asking. He's asking what is the difference in subscription of scheme 5 between December and January. So he's asking for a difference of a subscription of scheme V between December and January. So December data is 160 and January data is 80. So what is the difference? So we clearly have to do 160 minus 80, and all the values are in crores. So it has to be 160 minus 80 crores. This has to be the value, which is coming out to be simply 80 crore. Let us see the options. Whether we have got options. No, 80 crore is not available in the option. So the right answer becomes simply none of these. Okay, so the next question is, if the subscription to a scheme is the criteria of popularity, which of the scheme can be termed as the most popular? Okay, so that particular subscription would be most popular, for which the total number of subscription have been highest. So we have clearly supposed to find out the highest number of subscription done. Okay, and that will be the answer itself. He's asking which of the scheme can be termed as the most popular. So for all the schemes, we have to do the totals over the entire month. So we have to do like all these to be added together. Okay, we have to add them all together and we'll write total here. Similarly, we'll have to do the total of W and write it here. Similarly, we have to do the total of X and write it here. And we have to do all the totals. And after checking all the totals, then we'll be able to find out which, for which particular subscription the total is highest. That would have been the most popular subscription. So we have added it. So for the category called as Z, if we add the numbers are 10 plus 290 plus 160 plus 130 plus 140 plus 390. If we add all these numbers together, the total becomes 1120, and that is found to be the highest subscriptions for all the categories. So for type Z is the right answer. The total of type Z is highest among all. So that is the right answer, which is available in which option? It is available in option number E, becomes the right answer. Now, again, the same data is presented. Now, this time around, he's asking in which of the following months the total subscription to W and X scheme was equal to subscription to W scheme in February 99. So let us first find out what is the W scheme value in 1999. Okay, W scheme value in February rather. W scheme value in February is the value 150. So we have to compare any total with 150. What is that any total? The total subscription of W and X. So we have to do for W and X, and then we have to compare it that for which particular month the total of W and X is actually becoming equal to 150. So if we check one by one, total of WX in the year 70 in the month September is 100, that is not equal. In the year October it is 200, that is also not equal. In 35 plus 25, that is also not equal. 110 plus 40, this is how 110 plus 40 will give you 150. So this is that particular month, the month called as December, where the total is coming out to be 150. So that is the right answer. The month of December is the right answer. Now, the same data is there. The question is different. For which of the following types of scheme was there continuous decrease over the years? So we have to see the schemes all together, and then we have to we have to observe that for which particular scheme there is a continuous decrease. So if we see it like that, V is becoming 200, 120, 45, 160, but that here it is an increase. So V is not continuously decreasing. Similarly, W has increased in the very beginning. So this is out. 30 becomes 70. There is an increase. This is also out. Y becomes 290, then 150, then 125, then 150. So this is the one which is continuously decreasing scheme called as Y. So the right answer is option number D, that is Y. There is a continuous decrease. Now, for the same data, the question is what is the percentage increase in the subscription to Z scheme from January to February? For the Z scheme only, we have to tell percentage increase from January to February. So this is the Z scheme, January to February. January value is 140 and February value is 390. So we have to find out what is the percentage increase from 140 to 390. That can be found out by percentage increase is larger value minus the lesser value divided by the old value. Always old value is of January, that is 140 into 100%. So if we solve this further, this becomes like 250 by 140 into 100%, and 250 by 140 into 100%. If we do, this comes out approximately equal to 180%. Okay, so let us see where it is available in the options given to us. It is not available in the options, so clearly the answer becomes E, none of these 180%. Now we have a different data this time, and the data, let us read the data first, then only we can understand the question. Based on the table, figure in lakh units. So all the values are in lakh units. Okay, there are manufacturers of scooter and manufacturers of motorbikes. Okay, so for the scooter category, there has been different type of model available. Bajaj is a model, Maharashtra Auto is a model, LML is a model. For the Bajaj company, in 1990, we can say in 1992 and 1993, the sold units are 199. For the same Bajaj scheme in 1993, 1994, the sold are 221, and so on. We can understand, and the total has also been done for us. Like the total of 1992 and 1993 for Bajaj, Maharashtra Auto, and LMN has been done as 300 for us, and all these totals have been already done with us. Similarly goes for the motorbike category. For the motorbike category, Bajaj, Hero Honda, Escorts are there, and their totals and their sales are given respectively for the years, and the total has been also done year wise. Year wise total have been also done for us. So this is the data given to us, and they are saying the total, and there is a star, and they are saying it includes brands from other makers also. So there are some other maker also, they are which are creating the scooters and bikes, so that can be found out later. So the question asked is, which brand of scooter had the maximum growth in 1993, 1994 over 92, 93? So we have to see the scooter category data only. For scooter category data, which year the maximum growth is seen from 93, 94 over 92, 93, 1994 to 1992, which particular brand has seen the highest percentage increase. So if we check that, so for the Bajaj, the increase is from 199 to 2. For Bajaj, the increase is 221 minus 199 over 199 into 100. This is the increase for Bajaj. Similarly, the increase for Maharashtra Auto will be in 1993, it is 48. Earlier, it was 45. So it has to be 48 minus 45 divided by 45, the older value, into 100%. And for the scheme called as LML, it has to be how much increase? 67, 32 to 67. So this has to be 67 minus 32 divided by 32 into 100%. This has to go like this. Okay, if we solve this, if we solve like that, so we're going to get the value. So the first value is coming out to be 11.05%. For Maharashtra Auto, it is coming out to be 6.66%. For LML, it is coming out to be 109.37%. So that becomes the highest, 109.37%. So that is available. So the right answer is LML, and let us see where it is available. It is available as option number B. So that becomes the right answer. Now he's saying for the same data, he's asking now, among motorbikes, which brand registered the highest growth in the sale in 94, 95 over 93, 94? So for motorbikes, which brand registered the highest sale from 94, 95 to 93, 94? So we have to compare these data where there has been a highest increase. Okay, so let us compare. So for the first value, it has grown from 48 to 54. So we have to compare for Bajaj motorbikes. Bajaj, we can say 84 minus 48 divided by 48 into 100%. That is the first increase done. So for Hero Honda, there has been from 64 to 87. So it has to be 87 minus 64 divided by 64 into 100%. Okay, for escorts, the growth is from 50 to 74. So it has to be 74 minus 50 divided by 50 into 100%. So if we calculate this data, this value is coming out to be 44.8%. This value comes out to be 35.9%. This comes out to be 48%. So if we compare these all three data, then we can obviously find out the highest one. That is happening for the Scots one. So that is the right answer, option number B. For the same data, now the question asked is, what was the unit sale of scooter of other brands in 1994, 1995? So let us find out for the case of scooter 94, 95. So this is the data. So 221 plus 48 plus 67 would have been the total sale of Bajaj, Maharashtra Auto and LML. How much is that? 221 plus 48 plus 67. If we add the sale of all these three companies provided, okay, that will be the ultimate sale. That is nothing but 294. Okay, so 294 is the total sale. Rather, if we add this is 189 plus 76. Okay, 1 plus 8, 9 plus 7, 6. 16, 6, 1, 2, 3 plus 4, 7 plus 6, 13, 3 carry 1 plus 2, 3. So 336 is the total sale of these companies together for the case of scooter itself. Okay, the 336 is the total sale from Bajaj, Maharashtra Auto and LML, and the total sale provided to us is 336. Total sale provided to us is rather 360. Okay, total sale that has been provided to us is 360. So we have to compare for 94, 95. Okay, so this was the data of 93, 94. We have to compare for 94, 95 rather for the case of scooter. So clearly we have to compare this particular data. Okay, we have to compare this particular data. So the sale of Bajaj, Maharashtra Auto and LML, the total is how much? Sale of Bajaj Auto, has to be 294 plus 48 plus 87. Okay, this is the total sale. This is the total sale of these three companies, but he's asking for the other brands. The other brand can be calculated as total sale that is provided as 443 minus the total of all these three sales that have been provided to us, that was 294 plus 48 plus 87. This is how we can find out the other branch or the other maker's sale by subtracting it from the total value, and the total value is 443 minus, we have to subtract this. Okay, if we subtract this like that, and by doing the addition, we can find out the value comes out to be 14. And obviously all the units are given in terms of lakh units, so it has to be 14 lakh. That is the other maker's price value, which is available in option number A, becomes the right answer. Now, for the same data, we have begun the different question. The question is, what was the average monthly sale of scooters during the year ending in 31 March 1995? So we have to find out the average of scooter sale in the year 1995. So for that, we have to see the scooter data, and we have to find out in 1995. So clearly we'll have to see the 1995 data only. Okay, so the total sale of 1995 is 443. This is the sale of the complete year. So what will be the per month sale? Okay, we have to find out the average monthly sale. So average monthly sale will be calculated by total sale of the complete year, that is 443, divided by how many months are there in a year is 12. So this is the average total divided by 12 months, and obviously the unit will be in lakh rupees. So if we calculate this, this exactly comes out to be 37 lakh. Okay, so that is the average monthly sale of the scooter category for 1995. So that is available in option number C, 37 lakh. Now, for the same data is asking a different question. What is that question? Which of the following statement can be inferred from the data given in the above table? So there are statements given to us. We have to find out which particular statement is exactly right. Okay, so let us do it. Okay, the first statement says Bajaj scooter registered the highest sale in 94-95, but its cumulative growth rate did not register any increase. Cumulative growth rate did not register any increase in the sale over the previous year. So we have to check for 94-95 for Bajaj scooters. Okay, so Bajaj scooter 94-95, the value is 294. He's saying Bajaj scooter is the highest sale in 94-95, but the cumulative growth rate did not register any increase in the sale over the previous year. So the cumulative growth rate can be calculated by uh, adding 294 plus 48 plus 87 and then comparing it with the previous ones. So if we add 294 plus 48 plus 87 and compare it to the previous one, we can find out the different totals. And obviously the total registered in 1994-95 is higher than total registered in 1993-1994. That means there is a cumulative growth over there. Okay, for all the scooters types, there is a cumulative growth. What he's saying, they did not register cumulative growth. So that means this statement is false. There is a continuous growth. Okay, 221 becomes 294, 48 remains the same, but 67 becomes 87. So that is a cumulative growth. Okay, so this data is wrong. If we see question number 2, statement number 2, sale of Maharashtra auto scooter had registered the highest growth rate in 93-94 over 92-93. Let us check for sale of Maharashtra auto scooter for 93-94. Maharashtra auto scooter 1994 is 48, and the previous year it was 45. He is saying that this has registered the highest growth, and the earlier one was 199 to 221, 32 to 67. In the first question itself, we found out then for LML the percentage growth rate was highest. So that means this statement is also wrong. It's not the Maharashtra auto, but it is rather the LML that has registered the highest growth, growing from 32 to 67. So this statement is also false. If we see third, there was no change in the unit sale of scooter of other brands in the 3 years. So he's saying other brands sale has not been changed. Okay, no change in the unit sale of scooters of other brands in the 3 years. Okay, so we'll have to compare that data. So for 92-93, what is the other brand? Okay, for that we need to find out 300 minus 199 plus 45 plus 32. 399 minus 300 minus 192, that is nothing but 300 minus 199 plus 45 becomes 244. 244 plus 30 becomes 240. 244 plus 32 becomes 276. 300 minus 276 is clearly 24. So this is coming for 24. Let us see what is coming for 93-94. Total is 360 minus, what is the total of 221 plus 48 plus 67? 221 plus 48 plus 67. Okay, this is 360 minus 1 plus 8, 9 plus 7, 16, 6. Carry 1 plus 2, 3 plus 4, 7 plus 6, 13, 3. Carry 1 plus 2, 3. 360 minus 336, that is also 24. And if we compare for the last one also, 294 plus 48. 294 plus 46 would have been 340, and this is 342. 342 plus 87. Okay, 342 plus 87 would have been 4 429. And if we subtract 443 minus 429, that is also becoming 24. So he is right when he says there was no change in the unit sale of scooter for other brand in 3 years. For every time the other brand sale is coming out to be 24, 24, 24 only. So statement number 3 is completely right. Let us check for statement number 4. Though unit sale of other brands of motorbike was less than that of leading brands in 93-94, they registered the highest growth rate over 92-93. He's saying motorbikes, uh, the unit sale of other brands of motorbikes less than that of leading brands, and they register the highest growth rate over 92-93. So we can compare this data. He's saying the leading motorbike brands registered the highest growth rate. The motorbike brands are Bajaj, Hero Honda, Escort, and we have to compare for 93-94 only. Okay, which is the middle one. So we have to see what is the growth rate here. Unit sale of motorbike was less than that of leading brands 93, but they registered, which all registered, these three only registered highest growth rate over 92-93. So we have to compare whether they registered the highest growth rate. What is the growth rate of the other brands? Let us find out first. For finding out the other brand growth, we have to subtract, like for uh, for the year 92-93. Let us see for the year 92-93, what is the other brand sale. Okay, for that we have to subtract 162 minus the sale of all the other brand, that is 46 plus 56 plus 50. Okay, if we find out this is 162 minus 46 plus 56 plus 46 plus 56. So 6 plus 6, 12. 12, 2 carry 1, 4, 5, and 5, 10, and 5, 15. 152, that is nothing but 10. Okay, so the other brand sale in this year is 10. Let me write it here itself. 10 for the year 92-93. For 93-94, how much it is? For 93-94, how much it is? So for that, we need to subtract 187 minus the sale of other brands in 93-94. That is 48 plus 64 plus 50. Okay, if we add this together, this is 187 minus 48 plus 50 plus 48 is 98. 98 plus 64 is 162. 187 minus 162 is 25. Okay, is 25. So here the growth rate is 25. So the growth rate has gone from 10 to 25. Okay, and if we compare the growth rate of these brands, that is we can add 48, 64, 50, that was 162. So the growth rate for the main brands were, they grow from 152 to 162. So that's what they are saying. They registered the highest growth rate over 92-93, and this statement is also right. Okay, fourth statement becomes also right. So right answer is option number C. Okay, so now we have got a different question. The data is same, but we have got a different question. What is the different question? What was the unit sale of motorbikes of other brands in 93-94? Unit sale of motorbikes of other brands in 93-94. So this is the motorbike category, other branch in 93-94. So here we can find out. So motorbikes, other branches, other makers. Obviously, that can be found out by total sale minus the sale of Bajaj plus Hero Honda plus Escort. This is how we can find out the other maker sale. So total sale is given 187 minus Bajaj is 48 plus 64 plus 50. So if we add and subtract, it's going to be 187 minus 48 plus 64. So 8 plus 4, 12 plus 0, 12. 2 carry 1 plus 4, 5 plus 6, 11 plus 5. 16, 162. So the difference comes out to be 25, and the unit is always lakh. So it has to be 25 lakhs. Okay, let us see where it is available. Okay, 25 lakh becomes the right answer. Let us see where it is available. Okay, there are options given to us. We have to see and find out. Okay, for this particular question, 25 lakh has to be the right answer, because 187, the sale was to be find out for 93-94 only, and that's what we have done. 187 minus 48 plus 64 plus 50. 64 plus 40, 50 would have been 64. 64 plus 50 would have been 114. And 114 plus 48 would have been 162. 187 minus 62, that's we have to do. 162 minus 87 is 15 lakhs, not 25 lakhs, rather it is 15 lakh. And let's see where it is available. It is available in option number D, 15 lakh. That becomes the right answer. Okay, so we have a different question now. There is a line graph given. What are they saying? Study the given graph and answer the following question. There's a graph given. So this is speed on the y-axis, time in the x-axis, and from 0 to 10, 10 to 20, the speeds varies, and the time from 1 hour to 2 hour, 2 hour to 3 hour, 3 hour to 4 hour, and 4 hour to 5 hour, and so on. The time has been given to us. Okay, so let us find this out. Okay, so the question says there is a data given to us, okay, in which that there is a line graph given. Let us understand the data first, study the given graph, and question that follows. After how many years the train in the above graph will travel a distance of 100 kilometer? That's the question. Okay, so he says, after how many years, hours, the train in the above graph will travel a distance of 100 kilometers. So let's see the graph first. So there is on the x-axis, there is time in hours. On the y-axis, the speed in kilometer per hour is given. So this is a speed time graph as written as the title also, speed time graph of a moving train. Okay, so we can understand that from 0 to 1, the speed is 20 kilometer per hour. From 1 to 2, the speed is again constantly 20 kilometer per hour. From 2 to 3 and 2 to 4, rather, the speed increases this way. And from 20, it reaches from 20, it reaches to a point 60 kilometer per hour, and so on. It continues. So clearly, we'll have to make a particular table first, so that we can actually find out in what particular hour, in what particular duration, how much the train has traveled, and then in detail we can answer all the question depending on the chart. Okay, so let us see that chart, how we can make it. Okay, so what can be done? See, we have to see the graph also. Now let us say hours. The first title is hours, then we can have average speed. Okay, the next title can be average speed, then the title can be the distance traveled. Okay, distance traveled in that particular hour, and the total distance. We can also have accumulating total distance, okay, after every hour is completed. So let us see the hour. First is 0 to 1 hour. Then what is happening in 0 to 1 hour? What is the average speed? Obviously in 0 to 1 hour, if you see the graph, the speed is simply 20 kilometer per hour. So we can simply write it as 20 plus 0 by 2. That is the average speed. That is nothing but 20 kilometer per hour. So this is the average speed from 20 plus 0 by 2. That is going to be 10 kilometer per hour. So that is the average speed from 0 to 110 kilometer per hour. Now, how much is the distance traveled in this 0 to 1 kilometer? Okay, so the speed is 10 kilometer per hour. So obviously in 1 hour, the distance traveled would have been 10 kilometer. Okay, distance traveled would have been 10 kilometers. So total distance also covered is 10 kilometer only. Okay, now if you see from 1 to 2 hour, what is happening between 1 to 2 hour? If you see the graph, the speed is consistently 20. Okay, in the graph, the speed is constantly 20, so the speed becomes 20 kilometer per hour. Okay, so with 20 kilometer per hour, how much distance will be traveled in 1 hour? Obviously 20. So the distance traveled here will be 20 kilometer. So accumulated distance, the cumulative distance become 20 plus 10, that is 30 kilometer. Now we can have the same data for 2 to 3, 3 to 4, 4 to 5, 5 to 6, and then we can continue this 6 to 7 and so on. So for 2 to 3, let us find out the from 2 to 3, you can see from 2 to 3, we can see that the graph varies from 20 and ends at 30. Okay, graph starts from 20, and from 2 to 3, if you want to see, the graph starts from 2 value is at the 2th hour, the value is 20, and at the 3 point the value is 40. So the speed starts from 20 to 40. So here, so clearly the average speed is 20 plus 40 by 2. Okay, 40 plus 20 by 2 is nothing but 30 kilometer per hour. That is speed between 2 to 3 hour. Okay, so with 30 kilometer per hour, the in an hour the distance travel would have been simply 30 kilometer. So earlier the distance covered was 30. Now the distance will be 30 plus 30. This is how we are adding it, making it 60 kilometer. Okay, now between 3 to 4 hour, what happened? That speed started from 40 and ended at 60. So the average speed become 40 plus 60 by 2. Okay, that is nothing but 100 by 2, that is 50 kilometer per hour. So that is the speed in between 4 to 5 hour, 40 to 50 kilometer per hour. So obviously the distance travel would have been 50. Okay, the distance traveled would have been 50. So if this 50 is added to this 60, the total distance traveled becomes 110 kilometer. Okay, we have to continue making this particular table. He's asked after how many are the train in the above graph will travel a distance of 100 kilometers. So clearly we have reached to a point when the total distance traveled by the train is 110 kilometer. And in the earlier hour, the total distance traveled by the train was just 60 kilometer. So obviously from 60 to 110 would have been covered between the range of 3 to 4 hours. So that should become the right answer, that between 3 to 4 hour only, the total distance traveled has crossed 100 kilometer mark. So the right answer for this particular question becomes 3 to 4 hours. Okay. Now we can continue with the same chart, and that the data of this chart will be used in the next further next question also. If you go for 4 to 5 hours, if you go to for 4 to 5 hours, okay, then what we can do for 4 to 5 hours, from 4 to 5 hours we can see the speed value is remains 60. It has become constant at 60. We can see this. So the speed value from 4 to 5 hours is simply 60 kilometer per hour. Okay, so if the in an hour 60 kilometer are covered, so the distance traveled is simply 60 kilometer. So the total distance traveled is 110 plus 60, that makes it 170. Okay, for the 5 to 6 hours, what we can do, from 5 to 6 hours, if we see the chart, so speed is again constant at 60 kilometer per hour. So this is again 60 kilometer per hour. So the distance traveled would be again 60 kilometer in an hour. So total distance is 170 plus 60, that is nothing but 230 kilometer total distance traveled. 6 to 7 hours, what is happening between 6 to 7 hours? Now the speed is increasing. Okay, the earlier the speed was 60, now the speed has become 70. So the average speed becomes 60 plus 70 by 2. The average speed becomes 60 plus 70 by 2, that is 130 by 2, that is nothing but 65 kilometer per hour. This is the average speed between 6 to 7 hours. So the total distance traveled will be obviously 65 kilometer, and the total distance traveled accumulated one will be 230 plus 65, that is nothing but 295 kilometer. If we scroll it down further, before scrolling it down, we can see the next data for 7 to 8 hours also we have to see. So let us check the table. Let us check the graph between 7 to 8 hours. At the seventh hour, the speed is at 70 kilometer per hour, and at the eighth hour, the speed is somewhere at 50 kilometer per hour. Okay, so the average speed between 7 to 8 hour becomes 70 plus 50 by 2. Okay, that is nothing but 120 by 2, that is 60 kilometer per hour. So that is the average speed between 7 to 8 hour. With the 60 kilometer per hour speed, the distance traveled would be obviously 60 kilometer only. So how much is the total accumulated distance now? 295 plus 60, that is nothing but 355 kilometer. That much distance has been traveled. Let us move further. Between 8 to 9, what is happening? If you see the chart further, between 8 to 9, at the point 8, the speed is 50, and at the point 9, the speed is 40. Okay, 50 and 40, these are the speeds. So our average speed becomes between 50 and 40, that is 50 plus 40 by 2, that is nothing but 45 kilometer per hour. That is the average speed, kilometer per hour, with the average speed. So obviously the distance traveled would have been 45 kilometer. Now, if the distance would have been 45 kilometer, total distance covered is 355 plus 45 is nothing but 400 kilometer have been covered now. Let us see the last hour. The last hour is 9 to 10, between 9 to 10. At point 9, the speed is 40 kilometer per hour. At point 10, the speed is simply 20 kilometer per hour. So between 9 and 10 hours, between the ninth and the 10th hour, the speed varies from 40 to 20. So the average speed is 40 plus 20 by 2, that is nothing but 30 kilometer per hour. Okay, so the total distance traveled would have been simply 30 kilometer, and the total distance traveled after the 10th hour is completed would be 400 plus 30, that is nothing but 430 kilometers. So this is the final chart where we can see all the speeds, all the average speeds, all the distances, and the total distance as well. We're going to have to use this particular chart for further questions also. So we can mark this particular chart as the important one. Okay, so let us, and if somebody wants to calculate the average speed, okay, if somebody wants to calculate the average speed, so average speed will be calculated. The point, the important points here are the 430 kilometer is the total distance covered. Okay, the total distance covered in the entire journey of the train is 430 kilometer. That is the important point. Okay, so let us go to the next question. Now the next question says the average speed of the train is. So clearly the average speed can be calculated by the total distance traveled by the train divided by total time taken. That is how the average speed is calculated. Clearly in the earlier chart we calculated the total distance came out to be 430 kilometer, divided by total time taken is from 0 to 10th hour. So total time taken is 10 hours. So what is that overall speed? That is clearly 43 kilometer per hour. That is the average speed of the entire journey, and it is available in option number A. Now, the same data to be used is asking what is the highest rate of acceleration. First of all, we need to understand what is acceleration. Acceleration is nothing but the rate of change of speed. By definition, we can write as change in speed. That is, or we can write it as change in the rate of speed. In the single term, we can write it as change in the rate of speed. Okay, change in the rate of speed. Okay, or by definition, we can write it as change in the speed divided by change in the time. That is how we can represent it as change in speed divided by change in time. This is how we can represent this. Okay, so let us just quickly see what is the change in speed, and he's asking for the highest acceleration. So let us see different changes in the speed, and this has to become across the per hour duration only. So if you see the graph, so between these 2 points there is no change, so the acceleration is 0. From 2 to 3, if you mark this point, from 2 to 3 the rate of change, the change is 20 km per hour. From 3 to 4 also the change is 20 km per hour. Here the change becomes constant, here the change becomes constant. From this point to this point the change is 10 km per hour. Okay, from this point to this point the change is the speed has dropped from 70 to 50, so it's again 20 km per hour. From this point to this point the speed has been dropped by 10 km per hour, and from the last it has been dropped from 40 to 20, so again the change is 20 km per hour. So we can say the ultimate total change is 20 km per hour. The maximum change is simply 20 km per hour in the speed, so the denominator becomes 20 km per hour divided by change in time. So change in time is always 1 hour only, because we have calculated everything for the 1 hour duration only. So we can simply write it here 1 hour. So by unit wise, this becomes 20 km by hour square. That is the maximum change in speed, or rather change in maximum rate of acceleration is 20 km per hour square. That is available in option number A. Now, for the same graph, we have to find out something else. If the rate of acceleration goes down after 8th hour, okay, the rate of acceleration is going down after 8th hour, the train will stop at what time? Okay, in what time the train will stop? So clearly we'll have to see the data first for finding out this. So he's saying that the rate of acceleration goes down after 8th hour. So let us see what is happening after 8th hour. This is where the train is. Okay, so if you see, uh, and we are supposed to find out the rate of acceleration. So rate of acceleration, or the rather the acceleration only. Acceleration can be found out at this point. So rate of drop in acceleration at 8th hour, we are about to find this. After 8th hour, what is the acceleration? Acceleration is change in the speed. So we can write it as speed at 8th hour minus speed at 7th hour. This is the change in the speed. As the formula of acceleration is change in speed over change in time. So the change in speed is speed at 8th hour minus speed at 7 hour. Okay, divided by the difference between 8 minus 7 hours. Okay, that is what is the acceleration. So speed at 8 hour is simply 70 km per hour as seen from the graph, and speed at 7th hour is simply 50 km per hour as seen from the graph. The total duration covered is 1 hour only, so it becomes 20 km per hour. Okay, this is what is the change in the acceleration is 20 km per hour square, rather, because there is a unit in the denominator also. So that is the acceleration 20 km per hour square after the 8th hour. Now we are supposed to find out a time. How can we find out the time? The time can be found out by, if we divide the rather speed, okay, the unit of which is kilometer per hour, by acceleration. If we divide the speed by acceleration, whose unit is kilometer by hour square, then what's going to happen? See the units only, kilometer by hour and divided by kilometer by hour square. If you do like this, then obviously the denominator can be swapped and written like that, kilometer by hour into r square by kilometer. This can be swapped like that. So kilometer and kilometer get cancelled. 1 hour gets cut with 1 hour. So you are ultimately left out with r. So that's what we're going to do also. We will divide our speed, rate of change of speed, with the rate of change of acceleration, and we're going to get the r value. So what is the change in the speed? Change in the speed is clearly written here. Speed at the 8th hour. Okay, what is the speed at the 8th hour? Is at the 8th hour, the speed is 20 km per hour. We're going to have to divide this by what is the speed at the sorry the speed at the eighth hour is 50 kilometer per hour. If you see the graph, speed after the eighth hour is this point, and this point is equal to 50 kilometer per hour. So this is 50 kilometer per hour divided by the acceleration which we just calculated is 20 kilometer per hour. So divided by 20 kilometer per hour square. If we calculate this further, this comes out to be 50 by 20 or 5 by 2. That is nothing but two and a half 2.5 hours. Okay, 2.5 hours is nothing but 2 hours 30 minutes is nothing but 2 hours 30 minutes. So that becomes the right answer. So after 2 hours and 30 minutes, the acceleration will become zero. So speed will also become zero. So the train will completely stop. So that is the answer, 2 hour 30 minutes. Now, for the same graph, he's asking if we consider 2 hour time period, then what is the second highest distance covered in one time period? So here the time periods are given for 1 hour. If we consider it as 2 hour duration, we are supposed to find out the second highest duration. Okay. So if we see from the graph and if we take 2 hour duration, so we can again make the chart from 0 to 2. We can say the total distance traveled. We have to find out highest distance. So from 0 to 2, the total distance traveled would be from 0 to 1, it was 10, and from 1 to 2 it was 20. So the 0 to 2 the distance traveled would have been 30. 2 to 4, 2 to 3 it was 30, and 3 to 4 it was 50. So 2 to 4, this would have been, oh, okay, before going 0 to 2 we can go for 1 to 3 also. There is a range in between. So for 1 to 2 it was 20, and for 2 to 3 it was 30. So the from 1 to 3 it would be 50. Okay, now we can go further. Now we can find out for 2 to 4. For 2 to 3 it was 30, and for 3 to 4 it was 50. So 2 to 4 it becomes 80. Okay, now for 3 to 5, for 3 to 4 it was 50, and for 4 to 5 it is 60. So for 3 to 5 it becomes 110. For 4 to 6, for 4 to 5 it was 60, for 5 to 6 it was 60 again. So for 4 to 6 it becomes 120. For 5 to 7, for 5 to 6 it was 60, and 6 to 7 it was 65. So 5 to 7 it becomes 60 plus 65, that is 125. For 6 to 8, for 6 to 7 it was 65, and 7 to 8 it was 60. So for 6 to 8 it becomes 60 plus 65, that is 125 again. For 7 to 9, for 7 to 8 it was 60, and from 8 to 9 it is 45. From 7 to 9 it becomes 105. For 8 to 10, okay, for 8 to 9 it was 45, and for 9 to 10 it is 30. So for 8 to 10 it becomes 75. So these are the 2 hour duration chart as referred from the very first chart that we solved in the first question of this particular line graph only. So we can clearly see the ranges, and we have to find out the highest. So obviously the highest is going to be 125. We are supposed to find the second highest rather. So second highest after 125 is simply 120 kilometers. So that becomes the right answer, option number A. Now, there is a different chart given to us. Okay, this is a line graph again. We have to see the line graph. We have to understand the line graph first, then only we can solve different type of questions. So the line graph suggests there is a graph given to us, and we need to understand. So there is a group called Dhaliwal group. Okay, there is a group called as Dhaliwal group here. Okay, in that Dhaliwal group, total turnover has been given. The above line graph represent the total turnover. Okay, and this has to go, I think, year wise. Yes, this has to go year wise because 78, 79, 80, 81, these are years. So year wise turnovers are given. Okay, the other graph represent net profit or loss, oblique loss. So there is a line given here. Whenever the dot is above this line, we are calling it as profit. Whenever the dot is below this line, we are calling it as loss. So this is that line which can discriminate between profit and loss. Okay, year wise. So this is all is given to us. Let us find out the highest percentage growth in the turnover of Dhaliwal group was awarded during. Highest percentage growth. So percentage growth, we need to understand what is percentage growth first. Percentage growth is always the new value, the grown up value, minus the lesser value divided by the lesser value into 100%. Okay, this is how we call it percentage growth. In new value, that is the increased value. Older value, that is the older value only, which is not increased. Okay, and the older value again, which is the basic value, into 100%. So let us find out the different percentage growths, and then we can register that for which particular year this is happening. So let us go option wise. The first option given to us is 86 to 87. So what has happened in 86 to 87? Let us see the graph and find out. So at 86, the turnover was 132.85. 87, it is 152.36. Okay, so we can find out for 86 to 87 as 152. We can approximate it as 152 only, minus 132 divided by older value is 132 into 100%. Okay, this is how we can find out the percentage growth for the first option, that is 1986 to 87. Now let us not solve this for now. We can solve this later on also, but we need to understand how we are supposed to calculate the percentage growth rather for 85 to 86. So for 85, the value of the turnover is 111.17, and for 85, 86 is obviously 132. So the percentage growth becomes higher value minus the lower value divided by the lower value into 100%. And so on we can calculate for 81, 82, 83, 84, and so on. So by after calculating all these value, and we are supposed to check it, and then we can find out the highest percentage growth. So let us check one more for 93, 83, and 84, so that the things become more clear. 83 and 84, so the 83 value is 70, older value is 70, we can see it here, and 84 the value is 98. So the percentage growth becomes 98 minus 70 divided by 70 into 100%. Okay, which is coming out to be 18 by 70, okay, into 100%. Had this been a 72 number, the percentage growth would have been 18 by 72. This can be approximated as 18 by 72 into 100%. 18 by 72 is nothing but 1 by 4 into 100%, and 1 by 4 into 100% nothing but 25%. So this has registered the highest percentage growth. We have calculated for all the values, and then you can check it also. So the highest percentage growth has been registered for 83, 84, whereas which is 25%. Now, for the same data, we have to find out something else. What is that? The trends for total turnover and net profit oblique loss were same for which year except. So what do we mean by this? We need to see the pattern. We need to see the pattern or the trends, that means whether it is a growing trend or it is a decreasing trend. This is what is trend means, growing or decreasing. Okay, increasing or decreasing. And we have to see the trends of total turnover and the trends of profit oblique loss also. And then we have to compare that for which particular year the trends don't match. That means maybe for any particular year that the turnover would have been going increasing, and the net profit oblique loss would have been going decreasing, or vice versa. Might be turnover is decreasing and the net profit loss is increasing. So wheresoever for which particular year we find it out that the trends are different, we have to answer that. Okay, so let us see for 80, 81 only. Let's go by option. So if you see 80 to 81, so between 80 and 81, you can see that the trend of the net profit loss is on the increasing side, like this. And what about the turnover trend? So between 80 81, the turnover trend is also on the increasing side. So both increasing. So this is not the right answer. 81 to 82, if you see, between 81 to 82, the trends are increasing and the turnover trends are also increasing. So it is not also the right answer. 82 to 83. 82 to 83, the profit oblique loss trend is decreasing, if you see, and 82 83, the turnover is also decreasing. So this is also not the right answer. If we go for the next option, 85 to 86, between 85 to 86, here if you see the trends of turnover is increasing, and 85 to 86, the trends of the profit and loss is also increasing. If you see, trends of profit and loss is also increasing. So this is also not the right answer. So 85 86 is also not the correct answer. Obviously the right answer becomes none of the above. For no such year as given in the option that the trends are in the reverse direction, one should increase and one should decrease. This is happening for no options available. That's why the answer becomes none of these. Okay, for the same graph, we have to answer something else. Which of the following years marked loss for Dhariwal group? Okay, so we just have to find out wheresoever the points are below this line, then only we'll call it as a loss. Whenever the dots are below this line, we'll call them as a loss years. Okay, so let us see the options. So if you see the options clearly, we can find out without seeing the option, we can see the graph also. Loss is here at 1980. Loss is here at 83. Loss is so we can see these 2 points, 80 and 83, and yes, 81 also. 81 is also below the line. So 80, 81 and 83, these are the points which are below line. So these are the loss years, so which is available in option number E, 1980, 81 and 83. That becomes the right answer. Now he's saying in which year was the recorded net profit as a percentage of total turnover was the highest. So we have to find out the percentage to be calculated as net profit. We have to calculate the percentage for net profit over turnover. This is how we have to find out the percentage. This is what he has given into 100%. This is how we have to calculate for every year that he has given amongst the option. So let us calculate for 1978 first. So for the 1978, the net profit, we have to see the graph. For 1978, the net profit is 1.65. So we'll have to take it as 1.65 divided by total turnover. In 1978, the total turnover is 40.40. So it has to be 40.40 into 100%. This will be the value registered for 1978. For 1987, what's going to be the value? Net profit at 1987 is 14.32 and the total turnover at this point is 152.36. So this has to be 14.32 over 152.36 and into 100%. Okay, this will be the net profit over percentage of total turnover for 87. Let us find out for 86. For 86, what's going to happen? For 86, the net profit is 20.73 and the turnover is 132.85. 20.73 divided by 132.85. This is registered for the year 1986. This has been registered for 1986 into 100%, obviously. Okay, let us see for the next year, 79 and 82, and we can register these value for all the years given also. So if we have a closer look at this and we are supposed to find out the net profit as a percentage of total turnover, so it is coming out highest for 1986. Okay, 20.73 divided by 132.85 into 100% is receiving the percentage value as 14.7%, which is highest among all these years given. So that becomes the right answer, option number C, 1986. Okay, for the same chart, now we are supposed to calculate how many crores or rupees would be the total turnover of the company in 1988 if the same percentage growth rate was maintained as observed in 1986 to 87. So first of all, we have to supposed to find out the percentage growth between 86 to 87 in the turnover. Okay, turnover, in the turnover, what is the percentage growth from 86 to 87? So let us see the values. Okay, 86 to 87, we are supposed to find out the turnover growth. So 86 to 87 we calculated in the last question also, but we can again calculate. Okay, for the turnover value at 86. Okay, so percentage growth, we want to calculate the percentage growth between 1986 to 87. This is what is our idea. So what is the value at 86 and 87 we have to compare. So the turnover value at 87 is 152.36 minus the turnover value at 86 was 132.85. 86 to 87 divided by the older value, that is always 132.85. Okay, into 100%. If we calculate this coming out to be 14.7%. Okay, the growth rate is coming out to be 14.7%. Then he says, now we have found out this percentage growth, that is 14.7%. He says our would be the total turnover of the company if the same percentage growth rate was maintained for the next year, for the year 1988, if we have to maintain the same percentage growth. So clearly from 87 to 88, we are again supposed to grow by the rate of 14.7% only. This is what it means. Okay, so we have to grow at the rate of 14.7% only after 87 also. So let us see the value at 87. Okay, so at 1987 the turnover value was 152.36. So in 1988 the turnover value should be 14.7% more than this value. So that has to be 152.36 plus 14.7% of 152.36. This will be the total turnover value in 1988 as per the question. If you calculate this is coming out to be 174.74. So that should be the increased turnover in 1988 by the rate of 14.7%. So this is available in option number C, becomes the right answer. Okay. Now we have a different chart and we are supposed to study this so that we can answer the questions given. Okay, so let us see the graph. So there is total revenue generated. So the first line graph, okay, this particular line graph, first line graph represents total revenues in crores. Okay, capital investment and net profit earned. So the second line indicates capital investment. The third, the belowest line indicates the net profit earned. So these are the three line graphs. These are three lines in a line graph which are representing total revenue, capital investment, and net profit sequentially. Okay, and this has been given for the year 65, 66, 67 to 1970. And on the y-axis we can see rate of growth. So obviously this has to be in percentage. If the rate of growth is given, rate of growth is always in the percentage. So let us see. Okay, the first question is percentage growth in total revenue was maximum. So we have to see the percentage growth was maximum in which of the particular year. So percentage growth can be calculated by the increased value minus older value divided by older value into 100%. But this can be observed by the chart also. Wheresoever you will have the maximum slope. Okay, this is very low slope, this is higher slope, this is very high, this is more higher, this is more higher. So wheresoever you will find the highest slope, that would have been the highest percentage growth. Okay, so if we observe the total, we have to see the total revenue growth. So if you observe the total revenue line, which is the topmost one, so we can easily find out wheresoever the graph is increasing at the very high rate, and this is happening for the year 1967 to 68. You can see the increased value from 70 to 90. Suddenly from 70 to 90 it has become from between 1967 to 68 it has become 70 to 90. Okay, so that will be the highest percentage growth, and if you want to calculate, this has to be 90 minus 70 divided by 70 into 100%. Okay, and this comes out to be 20 by 70 into 100%. If you calculate this further, this is coming out to be 200 by 7%. Okay, if you calculate this further, this comes out to be 7 to the 14 6 and 7 8 the 56.75 the 35 and 7 7 the 14, close to 28.7%. So that is the highest percentage growth. If we want to compare, then we can sequentially find out one by one for each year, but we have already calculated this. The highest percentage growth will be registered between 1967 to 68, that is from 70 to 90. So that is the answer on the 67 to 68. Now, for the same graph, we are supposed to calculate profitability is net profit oblique total revenues. This is the definition of profitability is given. Profitability is net profit over total revenue. This is the definition of profitability has been given for this particular question only. Net profit over total revenue. Then the Indian Express faced the lowest profitability during which year? So we have to find out during which year the ratio of net profit to total revenue is least. This is what we are supposed to find out. Okay, so clearly we'll have to write some datas. So we have to go year by. So if you go for 1965, net profit in the 1965, if you read the data, net profit in the 1965 is the profit line is the least line. The value is coming out to be 1.8. Okay, so it is 1.8 divided by the total revenue in 1965. We can see the graph, the total revenue is 52. Okay, so this is 1.8 divided by 52. 66, if you see, net profit is, if you see the below line, the value is 3 divided by, in 1966 the revenue part is 63, so it has to be 3 by 63. We can cut this number later on. Then 67, if you see the 67, the net profit is 3.7 from the graph, divided by the net revenue is 70, so 3.7 by 70. And for 68 we can find it as 5.4 divided by 90. For 69 we can find it as 8.5 divided by 115. So if we see these fractions and if we compare them mathematically, then obviously we can easily find out. For best way of comparing them is minimize them in the simplest form, and then we can take the LCM, or we can approximate them also, okay, as per the level of freedom we have got. So by comparing them and by calculating by using the LCM method, we are supposed to find out that the option number A is right. The 1.8 divided by 52 is the least ratio among all of them. Okay, 1.8 divided by 52, and that is also because of the reason that the numerator is least. Whenever the numerator is least, you will get the least fraction, and whenever the denominator is least, you will get the maximum fraction. So for this is getting applied both for both the cases. Numerator, out of all the fraction, numerator of this value is becoming least, and the denominator of this particular fraction is becoming highest. So that's why also 1965 becomes the right answer. Now, for the same data, we have to verify which of the following statement is true. So let us verify the statements. Between 1967 and 68, the rate of growth of total revenue generated was maximum. 67 to 68, the rate of revenue generated was maximum. This all we have to verify. Okay, rate of growth of total revenue generated was minimum, rather they say total generated was minimum. But in the first question itself we have found out that the rate of total revenue generated was maximum between 67 and 68. That was 90 minus 70 over 70 into 100. In the first question itself we have found out that this particular rate of growth was maximum. So how can it be minimum? So first statement is false. Second, the rate of growth of capital investment was 25% during 67 to 68. Rate of growth of capital investment. So let us see the capital investment between 67 to 68. And in 67, capital investment value was 13, as you can see it here. And in 68, the capital investment value is 15. So if you see the growth, okay, the growth can be calculated by increased value minus the lower value divided by lower value into 100%. This is how we calculate the growth of a capital investment. If we calculate this, this comes out to be 200 by 13%. 200 by 13.7% is 13% is never 25%. So this is also wrong. This statement is false. C. Between 1967 and 68, the rate of growth of total revenue generated was higher than the rate of growth of capital investment, but lower than the rate of net profit. Okay, we have to compare. So total revenue generated between 67 and 68, the revenue rate we have already calculated is 28.75%. Okay, we have to compare this with higher than the rate of growth of capital investment. So we have to see the rate of growth of capital investment between 67 to 68. Capital investment growth, that's what we are supposed to find out. So at 68, the capital investment is 15. We have already calculated this, I guess. Yes, 67 to 68, the rate of growth of capital investment we have already calculated. That was 200 by 13%. If we calculate this precisely, 200 by 13%, then this comes out to be 13 1 13, 7, 13, 5 65, 0.5, 13, 3 39, 11. That makes it 110, 13, 7 91, 13, 8 104. So this is approximately 15.38%. Okay, so clearly the total revenue generated is higher than this. But then he says, but lower than the rate of net profit. So let us calculate the rate of net profit. Okay, rate of net profit for the same year, 67 to 68. Net profit, the 67 rate of the value of net profit at 67, we have to see the graph. Okay, if we have a closer look at graph, the value at 67 is 3.7 and value at 68 is 5.4. So we have to compare like 5.4 minus 3.7 divided by 3.7 into 100%. This is how we have to find it out. Let us do it. So this will be coming out as, if we solve it down, this will be coming out as 5.454 minus 37. This is 13 and 4 17. So it's 1.7 divided by 3.7 into 100%. Okay, if we calculate this further, this is 170 divided by 3.7, or we can write it as 1700 divided by 37. We can calculate it this way also. 1700 divided by 37. That's what we are supposed to do. Okay, so if we calculate this, 1700 divided by 37, that will give us the actual growth, and the value comes out to be 45.94%. So clearly the capital investment, uh, the rate of net profit is 45.94, which is higher than the rate of capital investment, which is 28.75, and which is lower, and the capital investment growth is, total revenue growth is higher than. So we can make it like this. There's a range we can calculate. So the highest one is the rate of growth of, so the highest one is the rate of growth of net profits. This is the highest growth. Then comes the rate of growth of total revenue. Then comes the rate of growth of capital investment. This is what is the connection. So this is what is the connection given here also. Total revenue generated were higher. So total revenue generated is higher than capital investment, but lower than rate of net profit, which is visible lower than rate of net profit. So this statement is verified and it is completely right. So option number C becomes the right answer for this question. Now, for the same particular chart, we are supposed to calculate something else. The turnover index is, if the turnover index is total revenue generated divided by capital investment. There's a term defined turnover index. That is, the term defined turnover index is given by total revenue for a year divided by capital investment. Total revenue divided by capital investment for any year. Then we are supposed to find out, okay, what we are supposed to find out, we are supposed to find out then the index was peak at during which particular year the index, this particular index that whose definition is given, was highest. Okay, so we have to calculate for each year turnover index, total revenue divided by capital investment. Let us go for 65. Total revenue in 65 was 52 2 divided by capital investment was 7.37. This is coming from the graph. Then for 1966, it was 63 divided by 12. Okay, for 1967, it was 70 divided by 13. For 68, it was 90 divided by 15. For 69, it was 115 divided by uh, 115 divided by 19. So these are the value set. He's asking for which is the highest out of them. So you need to compare. Okay, if you compare them, 52 divided by 7.37 and 53 divided by, so we need to compare them like that. Okay, one way of comparing is taking their LCM, but we can have a little idea about this also. The rate of growth is, it can give you the combination also. So if we compare like these fractions, the 1965 one is 1965 is recording the index at peak, so that becomes the right answer, 1965. Now, for the same question, we are supposed to calculate if in 1969 we keep constant the total revenue generated. Okay, the total revenue generated has to become constant, and because the data is given till 1969 only, data is given till 1969 only, and he's saying for 1969 the total revenue generated is to be kept constant. Total capital investment and net profit is as in 1968. Okay, then the turnover index in 1970 will read, because the data for 1970 is not given, so he is giving some indication. So we can make a chart out of this. There is a growth rate, and a growth rate of 68 to 69, and then we can create for 69 to 70 as well. Okay, as per the data given. Total revenue, okay, see, let's see total revenue. So total revenue for the year 68 to 69 can be calculated as 115, that is value at 69, minus 90, that is the value at 68, divided by the value at 90. This is what we are calculating, the percentage growth, and the percentage growth comes out to be 30%. So for growth for the in the total revenue in 1968 to 69 is 30%. Now, so he wants us to calculate the we keep constant the total revenue generated. Okay, so the total revenue generated is to be kept as the with the same growth rate, that is 30% itself. So we have to generate the 30% growth in the 69 to 70 as well. In 69, the highest value is 115. So again, the same growth rate should be registered. So obviously, in 69 to 70, the next value should be 115 plus 30% of 115. The same growth is to be made constant. Okay, 30% of 115. This is what we are supposed to calculate. So 115 plus 30% of 115 is actually 130% of 115 directly. 130% of 115. If we calculate this is coming out to be exactly 150. So this value is exactly 150. Now, the next data for turnover index is nothing but the capital investment. So if you see the capital investment, okay, capital investment between 68 to 69 is obviously the 69 value is 19 minus 15 divided by 15 into 100%. This is the growth of capital investment between these 2 years, and this comes out to be exactly 27%. Now, the same 27% is to be carried out further between 69 to 70 also. So obviously, the value at between 69 to 70 will be 27% higher than the value recorded at 1969, that was 19. So clearly we have to grow it like 19 plus 27% of 19, that will be the value registered for the next year. So 27% growth means 127% of it, 19 into 127 by 100. If we calculate this coming out to be exactly 24. So the last value comes out to be 24. So clearly we can see for turnover index, we need total revenue and the capital investment. So turnover index becomes, for the next year, the turnover index simply becomes 150 divided by 24, okay, which is approximately equal to 6. Okay, which is approximately equal to 6. So that becomes the right answer, value called as 6, option number A. Now we have a different chart and we have to solve the questions or as per the chart given. So let us understand the chart for. There's a line graph. Okay, the graph above represents the statistics of blended yarns and yarns for a 7-year period from 1990 to 97. Okay, figure 1 and 2 represent statistics of blended yarns in particular, and figure 3 refers to yarns as such. So what all data is given? So the first is billion tons output. So the first figure represent figure number 1 represents the output as written there. Okay, what is the output of the production? Then figure number 2 represent what? Figure number 2 represents the plant utility as percentage of capacity. Okay, that how much percent of plant has been utilized, that is what is called as plant utility as percentage of capacity. Okay, so we can write it as percentage capacity of plant utility. Okay, not the plant capacity rather. And figure number 3 represents what? Figure number 3 represents the export to import. Okay, export to import ratios or export to import value for the year from 1990 to 1997. This is all is given in the chart, and then understanding this data, we can actually do the questions of the particular chart associated with the chart. Let us see the first question. Which of the following statement are true? So we need to see the graph and then answer. The question statement, the first statement is a drop in plant utilization levels was the cause of decrease of output of blended yarn in 94 and 97. He's saying there is a drop in plant utilization level and that is because of the decrease of output blended yarn. So let us see the output of blended yarn between 94 to 97. In 94 it was at this peak, and in 97 it has just dropped down to this, and the same trend has been seen in plant utility also. In 1994, it was at this peak, and 1997 it has also dropped down. And in between, also the trend is showing that yes, this could be a clear reason. So the statement number A is completely right. Okay. Then the production of blended yarn was recorded the maximum when the plant utilization was at peak. He's saying that production was maximum when the plant utilization was also maximum, and that is obvious. We can see in the first figure the production is maximum at this peak when, and in the same figure we can see this is happening for the year 94 only, that the production is maximum and the plant utilization is also at maximum. So clearly statement number B is also right. If we check for statement C also, drop in plant capacity was the cause of decrease in production of blended yarn production between 94 to 97. He's saying drop in plant capacity was the cause. So this statement could also be right, but if we see the options only, we can see that A and B is available. So we can always go for A and B option. So option number A and B becomes the right answer. They are the real cause. Okay. For the same graph, we have got a different question. The question says the blended yarn producing capacity in 96 was approximately how much billion tons? For that, we can use a formula. Okay. The formula says output is always equal to capacity, that is the plant capacity, into output is always given by the plant capacity multiplied by the percentage utilization. Okay. Percentage utilization of the plant. Okay, this is the formula that will always be utilized for solving these type of question. Output of the production, output is nothing but the production itself. The production is always the capacity of the plant. This is not the plant utilization capacity, but this is rather the capacity of the plant multiplied by percentage utilization of the plant, which is given in figure number 2. So this can be found used from figure number 2. This can be achieved from figure number 1, and the value of capacity can be obviously calculated. So let us see blended yarn producing capacity, that is the capacity in 96 were approximately how much billion tons. So for finding out capacity, what we are supposed to do, capacity can be found out by output divided by percentage utilization. Okay, capacity converted by output divided by percentage utilization. So output in the year 96 is, let us see the figure number 1. Output in the year 96 is close to 3.7, this value. So we can write it as 3.7 divided by percentage utilization in the year 1996. So percentage utilization in the year 1996 is this. So for this we have to read the data. See, 50 to 65, there is a growth of 15%. And this growth of 15% is divided between 1, 2, 3, 4, 5, 6, 7, and 8 small blocks, 8 small squares. So each square represents 15 by 8%. That is close to 2. That is close to 2. 15 by 7.5 would have been just 2. So if we approximate this, 15 by 8 has 2 only. So each box can be referred to giving you 2% growth. Okay, 2% growth each box is representing. This value is coming at this particular box. So how many boxes are covered till here? 1, 2, 3, 4, and 5 boxes have been covered. So we can easily write this as 10. Okay, so 50 plus 10 gives you 60. So the plant utilization capacity as in 1996 is clearly 60%. So 60, if it is percent, then we'll have to multiply the above term by 100. So this is what should be the right expression for finding out. If we solve this further, this comes out to be exactly 6. Okay, the installed capacity comes out to be exactly 6. Okay, so let us see where it is available. It is available in option number A, so it becomes the right answer like that. Now, for the same three graphs or the same line graphs, we are supposed to calculate a different thing. He's asking whenever the yarn export increased, subsequently the yarn imports decrease or vice versa, except in the year. He's asking that is as per the graph, whenever the exports are increasing, he is saying the imports are decreasing. Imports are decreasing for every year. It is happening most of the year. It is happening that exports are increasing and the imports are decreasing. He's saying when is the exception of this situation, that when which particular year this is not happening, that they are going in a reverse direction, in which particular year this is not happening, that year he wants to find out. So we'll have to observe the figure number 3 itself closely so that we can understand where the pattern is reverse. So between 90 and 91, see, this is decreasing and here it is increasing, so the pattern is reverse. 91 to 92, it is increasing, here it is decreasing, pattern is reverse. 92 to 93, it is decreasing, and in this trend it is increasing, so this is also reverse. 93 to 94 is always decreasing and here it is always increasing, so it is the same situation till here. Between 94 to 95 it is decreasing, and here in 94 to 95 it is also decreasing. Okay, between 94 and 95, see, between 94 and 95 here you can see there's a decreasing trend in the imports, and in the export there is also a decreasing trend here. So in 94 and 95 this is happening, that both the trends are decreasing. So this is that particular answer, 94 95, which is the exception of the trend. Now in the next question he says the blended yarn producing capacity was the lowest in. Okay, the formula for capacity, rather the formula for output is nothing but the capacity multiplied by plant utilization. Okay, plant utilization in terms of percentage. Plant utilization in terms of percentage. This is the formula as given for the first question also. So for this we can find out the capacity is equal to output divided by percentage plant utilization. Percentage plant utilization. This is the formula that can be used for finding out the capacity of each year. Okay, so we are supposed to find out the capacity. Let us go by options. So the first option is 1997. Okay, if you see for 1997, the the capacity can be found out by output. What is the output in 1997? Okay, for the output for the year 1997 is close to 3.6. So we can write it approximately 3.6 divided by plant utilization in 1996 is this value, which was calculated by us in the last question as 60. So we can write it as 3.6 by 60, as it was 60%. So we can write into 100 here. For 1996, we can calculate this as in 1996 the value is the value of the capacity in 1996. The value of the output is this value. So we can take it as somewhat close to 3.7 approximate, divided by the plant utilization percentage in 1996 we are supposed to calculate. So plant utilization percentage in 90, so the other one was 97, so this was not exactly 1 2 3 4 5. Okay, this was fine. The so for 1997 it has to be one block more up. 1 2 3 4 5 5 blocks have been covered, so it has to be 10, so it has to be a value 60 here. And for this it has to be 1 2 3 4 5, 1 2 3 4 and 4 only covered, so it was not 60, this was 58 rather. Okay, for this one it is 3.7 into 60, 3.7 divided 60 into 100%. Again, for 1995, if you see the output, the 1995 output value is somewhere here, which is somewhere between 4 and 4.5. So we can take it as 4.25, 4.25, and divided by the plant utilization in the year 1995. In the year 1995, the plant utilization is somewhere here. We can write it as, if each square block represents two units, 2% is 2 plus 2, 4. So it has to be 65 plus 4, that is 69, and obviously into 100%. Okay, for option number D, that is 1993, we can find out the same thing. So clearly we can write down all the values and then we can obviously compare. So after comparing them, we are reached to a result that the value of 1994 seems to be the maximum. So let us calculate the value of 1994 as well. Okay, so the value of rather 42. So we have to see this particular thing, the blended yarn. Okay, the blended yarn producing capacity was the lowest way to find out the lowest capacity. Okay, so and after observing all the data, we have reached to a result after calculating all the percentage values. This for this option as well, for this option as well. We have observed that the percentage capacity, production capacity of the blended yarn is lowest in the year 1997, which is the right answer. Option number A. Now, for this thing, we are again supposed to answer one question. He's saying the capacity utilization in blended yarn production was the maximum in. So this obviously can be understood by just watching the graph. He's saying capacity utilization has to be, or production has to be maximum capacity utilization. Okay, so this can be simply seen by the graph itself. So maximum utilization has been covered in the year, in this particular year, and this year is nothing but 1994. So that becomes the right answer. In 1994, the percentage utilization of the capacity is maximum. That becomes the right answer. Okay, so the question says there's a data presented, and as per the data, we have to solve the questions. Okay, so there is a question, there's a data. The data is about following graph shows the Mumbai Stock Exchange averages for over 12 months period. Answer the following questions. Okay, so if we closely look at the data, we can see on the horizontal axis we have got months from January to next year January again, and on the y-axis we have got the values of the stocks. Okay, and obviously these are average data, so for every month there is an average value of the value of the stock exchange has been mentioned, and for the period of complete 12 months, this is how the data is represented. Okay, so the first question says during which 3 months period did the stock market experience the greatest fall? So we just have to go by options, and whichever option is representing the highest fall, that will be our answer. So let us see the option January to March and March to May. Okay, if you see the graph, first option is January to March. So January to March, clearly there is no fall, there is a rise over. So that is excluded. Other one is March to May. If you see March to May, there where the March somewhere starts, and March to May there is there is continuous rise, there is sudden drop, and then again a rise. Okay, and if you see the other option, that is the option C. The option C says June to August. If you see from June to August, this is where somewhere June is, and August is somewhere here. So obviously there is a little rise, then there is little rise, and there is fall, and then again there is a rise. Okay, if you see from September to November, September somewhere here, and September to November, so there is a little rise, then there is drop, then again rise. But if you see the last option, that is November to January. So November is this, November is somewhere here, and then January. So you can see a very high drop. See, the value has dropped from 1620 to suddenly 1550, which is a quite drop, which is a quite high drop as compared to the other ones. So clearly the graph itself indicates that there's a drop of 70.5 points in just 3 months consecutively, and which is shown by the graph as well. So clearly, this is the right answer. From November to Jan, there has been registered the highest, greatest fall, or the highest fall. That is the right answer. Now, the same data is being used for the next question. Now, he's asking the average at the end of this year is approximately what percent of the average at the beginning of this year. So we have to see the end of this year, and we have to see its percentage with the beginning of this year. So at the end, we can see from the data itself, the end value is 1550. So that is the 1550, the average value at the end. In the beginning, if you can see the beginning part, in the beginning part, this is the beginning value at the month of January, and this is close to 1640. So the beginning value is 1640. He's asking at the end of the year is what percent of the average of the beginning of this. So end of the year value is 1550, beginning value is 1640, is what percent? So into 100%. This is how we solve. Okay, if we calculate this further, 155 divided by 164 into 100%, this is approximately coming as 94.51%. Let us see where it matches amongst the option. Okay, so it is available in option number D. It is close to 94, becomes the right answer. Now, the same questions to be targeted using the same chart. The question is, what is the approximate ratio of the highest stock exchange to the lowest value. So let us find out the highest one. So highest one from the graph can be found out as the peak value, which is here, which is nothing but 1700. So this is the highest one. We have to find out the ratio of highest is to least. So highest value is 1700. Let us see for the lowest one in the chart. Lowest can be seen as this, which is nothing but 1550. So 1700 is to 1550. That should be the right ratio. If we simplify this further, okay, this is coming out, and see, the options have to be tallied in terms of the ratio itself. So if we simplify this further, we can cut both the number by 5. So if you cut the 5 by 170, this is 30, if you cut it is 3.4, and if you cut this by 5, this is 5 3 are 15 and 5 into 5, so it has to be 170. So this is 3.4 is to 3.1. If we simplify this further, this is close to, if you cut both the numbers by some common number, this is somewhere close to 4.4 is to 4. Okay, 4.4 is to 4, or 3.4 is to 3.1. Let's see among the option. So clearly option A is only matching with it, because you can see the first number has to be on the higher side, which is happening in only this the B, D, E, and A option. And amongst D, E, and A, which is most close to the which option is more close to our right answer, that is 3.4 to 3.1, is nothing but 4.4 is to 4. So that becomes the right answer, option number A. Now the same data has to be used for next question, which says in which month was the average of the highest, and in which the month was the average the lowest. So we are just able to answer this. The highest value is obtained in this very at this very point, and if we bring it down, so it matches with the month called as June. So June has got the highest stock value, and the least value has been obviously registered in this month, which is January. So January and June should be the right answer. Okay, the least value has been achieved in the month of June. Okay, so highest value has been achieved in the month of June, and least value has been achieved in the month of January. So let us see among the option. Okay, in which month was the average the highest, and in which month was it lowest? The highest was in June, and the lowest was in January. So June and January is not given. So there is in the option June and December is an option. So yes, obviously June is the highest, so that the first part clearly matches, and December is not the least, but it can be registered as the second least among the options. So that's why June and December becomes the right answer. Okay. Now the same graph, we have got a question. What is the question? What is the approximate percentage decrease in the stock average from its overall highest point to the lowest value during the month of September? So only for the month of September, we have to find out the percentage decrease from highest point to lowest point. Okay, only in the month of September, highest point to lowest point. So let us see the month of September. This is how it goes. Okay, and it ends here. The month of September ends here. So this is the lowest point, this is the highest point. Okay, this is the highest point, and obviously this is the lowest point. If you tally the graph and find out the data, okay, so we can easily find out the highest point is, if you match it with here, the highest point is somewhere for the month of September only. We have to calculate what is the approximate percentage degree in the stock average of its rainfall of its overall highest point to the lowest value during the month of September. So if you look at it carefully, the highest point for the month of September to October somewhere goes to 1630, or we can take it as 1635 also, 1635, and the lowest value is registered here. If you match with the option, it's somewhere close to 1625. So clearly we have to find out the percentage degree. So we can obviously the percentage is 10. So highest percentage degree, so percentage decrease is always calculated by the decrease value, that is 10, over the least value. Okay, over the okay, highest percentage decrease has to be found out. So it has to be found out from the decrease values, which is 16 to 25 into 100%. This is what we have to solve. 10 divided by 1620 into 100%. So this is close to 1000 divided by 1625. Okay, which is can be registered as approximately equal to 5%. So that becomes the right answer. Okay. Now we have got a different graph, and it is nothing but a pie chart. Pie chart represents when the values are given in form of a circle, in form of a pie chart. Okay, so let us study the graph first. The graph indicates distribution of a family of expenditures. Okay, there are different component: food 30%, house rent 20%, miscellaneous 5%, and so on. It goes like this. Okay, and different components have been distributed in terms of the graph. Now he's saying the first question, if the family spent 3200 rupees per month, so the total expenditure is 3200, then what is monthly tax of the family? Okay, so the monthly tax item has been given as 12%. Okay, so if the total expenditure is 3200 rupees, then tax, this is the total expenditure. Total expenditure is 3200 rupees, then tax value should be, as they say, tax is 12% of the total expenditure. So we clearly have to find out the 12% of 3200. So that will be the exact tax value that is to be paid, divided by 100. So this is 32 into 12, which gives you a value of rupees 384. So that is the amount they pay in taxes. Rupees 384 becomes the right answer. Now, for the same graph, from the same pie chart, we have to solve a different question. How many degrees should be there in the central angle of the sector for education? Okay, so what is the concept of central angle? If we want to understand that, we can write as a formula also. Okay, central angle of any component of the pie chart divided by 360 degree is equivalent to value of the component divided by the total value or the total expenditure for this case. So this is how the angles are related in a pie chart. Central angle of any component divided by 360 degree is equal to value of that component in that pie chart divided by the total value of the whole pie chart. So if we see our graph, we can easily find out. So we are supposed to find out the how many degrees should be given to central angle of the sector of education. So we can clearly write the formula as central angle for education divided by 360 degree is equal to value of the component. So value of education. So value of education we can give in terms of percentage also. So education has been given 15%. Okay, so value of education becomes 15%. Okay. Okay, we are supposed to find out the angle for 15%. So 15 divided by total percentage is always 100%. So clearly we can solve the central angle. So if we calculate this, the central angle for education comes out to be 15 divided by 100 into 360. Okay, we need to solve this. So this becomes like 5 3 ja 15, 5 2 ja 10. So 2 cuts 36 by 18. So it comes out to be 18. So 15% was given for it. So it has to be 18 into 3, 54 degrees. So that what's become the central angle for the sector called as education, available in option number C. Now, for the same pie chart, we have to solve a different question. The question says, how many degrees should be there in the central angle to show education, taxes, and transport? So again, we refer to the formula central angle of any component divided by total 360 is equal to value of the component divided by total value. So let us find out the central angle. We can write it here. Central angle of education plus taxes plus transport. Okay, divided by total angle of a pie chart is always 360 degree is equal to value of these education, tax, and transport, so that we can add them together. Education is 15%, taxes is 12%, and transport value is 8%. So we can add these value always. 8 plus 15 plus 12 divided by total value of the expenditure can be taken in terms of percentage itself, that is 100. Okay, if we solve this further, this is giving us the angle is given as 15 plus 8, 12 plus 8 is 20 plus 15. So it is 35 divided by 100 into 360 degree. That will be the right answer. If we solve this further, we can cut down few things. And this is 5 7 ja 35, 5 2 ja 10. 2 cuts 36 by 18. So we have to find out simply 18 7 ja. The value of 18 7 ja is nothing but 126 degrees. So that is the angle corresponding to education, tax, and transport together. 126 degree, available in option number D, becomes the right answer. Now now we have a different chart, and for the different chart we have to calculate the value of the questions and the answer of the questions. Let us study the graph first. So the graph says the ICICI Bank in Ludhiana published the following pie chart for depositors. Okay, what all deposits are there? So we have to see that. So the largest one is mortgages. Mortgages is 58.6%. Cash on hand is given as 3.9%. Bonds in terms of 29.3%, and stocks in terms are 5.2%, and other assets are 3%. So these are the different different let us say the deposit distribution has been given. Now let us see the question. The question says average annual interest on mortgage investment is B%. Okay, so interest on the mortgage is B%. Here, the data of the mortgage is just given, not the interest part. Now they are declaring the interest over that also. They said there is a B% interest available on the mortgages, and the average annual interest of the bond investment is C%. Okay, on the bonds you can have a C% interest retrieved if the annual interest on the bond investment is A rupees. So interest on the bond is given as A rupees, where the percentage value on the interest of the interest on the bond is given as C%. How many rupees are invested in mortgages? This is what is the question asked. So first of all, we need to see that they have given annual interest rate. Okay, annual interest rate on bond investment is given out to be C%. Okay, and annual interest value on the bond, annual interest value of the bond is A rupees itself. So we can clearly say that C% of the bonds, we can clearly say interest. How can we calculate the interest? Interest can be calculated as C% of the bond value. Okay, C% of the bond value, and that is given already as A. Okay, so the C% of the bond value is the interest rate, and that is already given. The interest amount is already given as A. So clearly we need to place the bond value here. So we can write C% of the bond value. Bond value is given as 29.3%. Okay, C% of the 29.3% of the total value. We can write it like this. Total value is clearly A. C% of the 29.3% of total value is A. This is what we can establish. Now he says, what is the he's asking how many rupees are invested in mortgages. Okay, so in mortgages, obviously double the 29.3% would have been invested. Okay, so C% of 29.3% of total of A is coming out to be this. Let us assume 29.3% of total to be Y. Let us assume 29.3% of total to be Y. So we can clearly write C% of Y is A. Okay, we can write this like this. So let us find out the Y's value. So it's going to be C into Y by 100 value will be A. So clearly Y can be calculated as A into 100 by C. This is the Y value. And in actual, what is Y? The Y is nothing but 29.3%. So we can write 29.3% of the total value is A 100A by C. That is the 29.3% of the total value. What he has asked us to calculate, how many rupees are invested in mortgages. So 29.3% of the total is 100 by say mortgages. In mortgages, how much has been invested? 58.6% of total has been invested. 58.6% of total has been invested, which is clearly the double of 29.3%. So we can easily say that in the mortgages, double the amount of the bond has been invested. So how much is the amount of the bond? That is 100A by C. So how much should be the amount of mortgages? Will be double the amount invested in the bond. So that will be 2 times 100A by C, and that will be nothing but 200A by C. So that should be the right answer. 200A by C. Let us see where it is available. It is available in option number E becomes the right answer. Now, for the same pie chart, we have to answer a different question. Now, the question says about how many degrees are in the angle of the sector representing mortgages. So we have clearly supposed to find out the central angle of mortgages. We have got a formula for central angle of mortgages. What is that? Central angle of a component, okay, of a component divided by 360 degree is actually equal to value of that component in the pie chart divided by total value of the pie chart. This is what is the formula which can be applicable. We are supposed to find out a central angle corresponding to mortgages. So that can be found out. Mortgages angle is divided by 360 degree is equal to value of the component. Value of the component is 58.6%. Value of the mortgages in the pie chart. Total value of the pie chart is obviously 100%. Okay, if we are supposed to solve this further, if we solve this further, the angle M comes out to be somewhat around 586 divided by 1000 into 360. If we solve it, it comes out to be precisely 210.9 degree, which is very much close to 211. Okay, so the right answer is 211 degrees. That is becomes the right answer. Now, there's the next question. There is again the same pie chart being repeated. Now, they are asking what percent of amount of cash on hand is the money invested in stocks. Okay, so cash on hand amount is what percent of the stocks. So cash on hand amount is, we can solve this question in terms of percentage itself. We don't need to convert the percentage value into the total value. Okay, so let us find out. He's saying the cash on hands is what percent of the stock. So cash on hand value has been given in the pie chart as 3.9%. Okay, and money invested in stocks, so stocks amount has been given in terms of percentage as 5.2%. So clearly we are supposed to find out 3.9% is what percent of 5.2%. How we can find it out? That 3.9 is what percent of 5.2. So 5.2 becomes denominator, 3.9 becomes numerator into 100%. Okay, so if we solve this, we can obviously find out 3.9. Rather, he has said what percent of the amount of cash on hand. So after off, he has said cash on hand. So we have to put the cash on hand in the denominator side. We have done it different way. The cash on hand has to go on the denominator. Whatever appear after off, that becomes the denominator. After of appearing is cash on hand. So cash on hand should become the denominator. So we should drop 3.9 in the denominator. 5.2 should become the numerator into 100%. This is how we are supposed to solve this question. And if we solve this, both the numbers can be cut by 13. 13 3 ja 39, 13 4 ja 52. So it's 400 by 3%. Okay, it comes out to be 400 by 3%, which is exactly equal to 130.33 bar percent, and that is available in terms of option as option number E. Now, for the same pie chart has been repeated for the next question. They are asking annual rate interest from other asset is 4.8%. Other asset is annual rate interest. Okay, the interest rate for the other asset has been given. In the pie chart, only the distribution of the depositor has been given, but the interest rate has been defined in this question. Annual rate interest of other asset is 4.8% interest. Okay, if the total asset of the bank are 57.6 million rupees, total asset value has been given for the very first time is 57.6 million rupees. What is the annual income in rupees from other assets? So total value has been given as 57.6 rupees. That is that this distribution is of total money of 57.6 million. Okay, this distribution is of 57.6 million rupees, which can be distributed in different components. And he's saying interest on the asset is 4.8%. So what is the interest? What is the money earned? So clearly the money earned will be total deposit, whatever the total deposit, that's uh, we have to earn money from the other asset, that's 3%. So the 3% of that, 3% of that will be the value of other assets. Okay, this will be the 3% of the total deposit, and its itself 4.8% will be the interest earned. Its 4.8% will be the interest on the other assets. Okay, total deposits 3% as per the chart is the other asset, and other assets 4.8% is the interest value. So we can do it directly. Total deposits 3%, 3%, 4.8% is our answer. So let us put the values inside. So total deposit is, as in the question given, 57.6 million rupees, and it's 3% we have to find out, divided by 100 into, and it's 4.8% also we have to find out. So we have to solve this big numbers, and after solving we can easily get the answer. So while solving, we can give you the right answer. The direct answer comes out to be rupees 82,944. So these many rupees have been earned by the ICICI Bank from in the form of other assets interest. So that is the right answer, option number A. Now we have a different pie chart and we are supposed to solve the question using this pie chart. Okay, now there are two pie charts given. Okay, and clearly there will be a strong connection. Let us see that. So we need to understand the pie chart first. Pie chart showing labor and amenities cost, budget, total, and percentage of various allocations. So we can see 10.4 lakhs. So in the year 1986, the budget was 10.4 lakhs, and the distribution of that has been given in terms of the first pie chart. for different heads like canteen expenses, recreation and entertainment, health and accidents, social security, and contingencies. The same distribution has been provided for the 1999 1996 also. This time around, the budget was 103.2 lakhs. So the later distribution, this distribution is from 103.2 lakhs, and the first distribution is from 10.4 lakhs only. Only the percentage values differ. Okay, let us see the question then. What was the increase or decrease in the allocation for social security and insurance from 1986 to 1996? We have to see whether there is an increase or decrease in the social security and insurance component from 86 to 96. So let us see the social security and insurance in 1986, that is the 9%. Okay, so the in 1986 that value is 9% of how much? 10.4 lakhs. This is the first value. And in 1996, if you see 1996, that very value is 7.3%, which is here, is nothing but 7.3% of, this time around it has to be calculated from 103.2 lakhs. Okay, and we have to see the increase or decrease. So in this case, we are not supposed to calculate the exact value. We can calculate approximately also as much as possible. So let us do some approximation. We have to find out 9% of 10.4 lakh. Rather, we'll find out 9% of 10 lakh. Okay, we can approximate this much. So 1986 value becomes 9% of 10 lakh, which is nothing but 0.9 lakh rupees. Okay, 0.9 lakh rupees for 1986. For 1996, okay, let us approximate once again. For 1996, it is 7.3% of 103.2 lakhs. How we can approximate? We can find out just 7% of 100 lakhs. Okay, so 7% of 100 lakh will be nothing but 7 lakh rupees approximately. So for 1996, it is 7 lakh, and for 1986, it is 0.9 lakh. So clearly there is an increase. How much is that increase? That is close to 7 minus 0.9 lakh. That is close to approximately 6 lakhs only. So this has been the increase register. So that's what is the answer. Plus 6 lakh becomes the right answer for the very first question. Now the same pie chart is to be repeated for a different question. Now he says a different thing. What is that? Consumer price index rose by about 280% from 1986 to 1996. Okay, consumer price index, that is the inflation, okay, has been rose by about 280%. What percent of the increase in recreation and entertainment allocation is attributed to inflammation? So clearly we are given a different set of values here. First of all, let us see if the consumer price index was not in the picture. Okay, if suppose the consumer price index was not in the picture, let us find out the values in 1986 and 1986 respectively for entertainment sector. Okay, let us find out this. So what is happening in the entertainment sector in the year 1986? If we see the graph, so in the entertainment sector, the value is 35.5% of 10.4 lakhs. How much is that? Obviously we'll use some approximation. 35.5% of 10.4 lakhs, that's what we have to supposed to find out. So this is approximately equal to 3.7 lakhs. Okay, 35.5% of 10.4 lakhs is approximately equal to 3.7 lakhs. So this is the value of entertainment in 1986. Okay, now let us find out in 1996. So what is the value in 1996 for the case of entertainment? It's written here 15.8%. 15.8% of 103.2 lakhs. Okay, rather the entertainment value is 45.2%, not 15%, it is 45.2%. So we are supposed to find out 45.2% of, this time around the total budget is 103.2 lakhs. So we can obviously approximate this. 45.2% of 103.2 lakhs can be approximated, which is approximately somewhat close to, let's say, 46.6 lakhs. And this is a mere approximation, 46.6 lakhs. So this is the value without the consumer price index risen consideration 1996. This is the value here. Okay, now let us bring the consumer price index in the scene. Had there was a consumer price index in the scene, so the consumer price index says the value has risen by 280%. Okay, risen by 280%. So let us see how much value would have been increased from 3.7 lakh if the consumer price index of 280% was in the picture. So 3.7 lakhs, 280%, that's what we are supposed to find out. What is the 280% of 3.7 lakhs? If we do this, this becomes 280% of 3.7 lakh. So that is 280 by 100 of 3.7, which is approximately close to 6.7 lakh rupees. So this was the value. If we would have considered the consumer price index risen by 280%, the next value would have been 6.7 lakh. Okay, now this is the 6.7 lakh, and let us find out the increase if the consumer price index was not in the scene. So that would have been the value of 1986 and value of 1996 minus the value of 1986. If we subtract 96 and 1996 and 1986 value, so this is 46.6 lakhs minus 33.7 lakhs, which is close to 43 lakhs approximately. So if the consumer price index is not in the scene, there is an increase of 43 lakhs in the entertainment from 86 to 96. If the consumer price index in the scene, there's an increment of 6 point lakh. So how much is the contribution of this 6 point lakh in the 43 lakh? That's what is the question. What percent of the increase or recreation and entertainment allocation is attributed to inflammation? Because of the inflammation, what is the contribution? So the inflammation, because of the inflammation, there's a price hike of 6.7 lakh, and total price like is 43 lakhs. What now the real question becomes, 6.7 lakh is what percent of 43 lakh? Okay, so 6.7 lakh is what percent of 43 lakh? So 43 comes down into 100%. That is the real question, and this will be the contribution of the inflammation in the rise of entertainment and entertainment value and irrigation value. So if we calculate this further, this is somewhat coming close to if we calculate this exactly, this is somewhere coming close to 15%. So that is the contribution of the inflammation. Okay, 15%, which is available in option number A, becomes the right answer. Okay, now the same pie chart is to be used for a different question now. Which item increased the least in rupees amount from 86 to 1996? Which item increased least? So obviously we can serve a theory for this. So in general, when we have to compare like that, so the item that would have increased least would be amongst the least area values. Okay, the least angle values will be somewhere amongst the least angle values. Those are your social security. See, the area or the angle is very less. Then higher than that is 13.81. This one is a little higher than this one, and the maximum values are these 35.5 and 25.1. So these will not consider. We'll only consider the values of social security, which is because the angle is very small. So wheresoever the total angle is small, there is expected to be the least increment also. So we'll go by this. We'll first of all check for social security because that has got the least angle. If not, then we'll go for the other increased value, that is health and accidents. Then we can also check our next value, that is nothing but your canteen expenses. We will keep on checking it like that, and whichsoever find is the least will become our right answer. Okay, so let us check it. Okay, so the first one is we have to check for we have to first check for social security. So we can obviously approximate here also. So if we approximate what has happened, okay, so if we approximate like that, that we can see that for the social security the value was 9% of 10.4 lakhs, and it has risen to 7.3% of 103.2 lakhs. So we can obviously approximate 9% of 10.4. We can clearly take it as 0.9, and 7.3% of 103.2. We can clearly take it as somewhat around 7 lakh. So 0.9 to 7 lakh, there is a rise of approximately 6 lakh rupees. Okay, this has been the rise in this category. Now let us go for the next one. Okay, if we see for our next thing, that is health and accidents. So health and accident value is 15%. So this was for social security. Okay, 6 lakh has come. Now we'll check for health and accident. For health and accident, the value is health and accident, the value is 15.8%. So from 15.8% of 10 lakh to it has risen to health and accident is 10.3% of 103.2 lakhs. This is how it has risen. So 15.8% of 10 lakh is somewhere 10% is 1 lakh. So it is somewhere close to 1.58 lakhs. And this is the next one is 10.3% of 103.2 lakh, that is somewhere close to 10 lakh only. So if we do the difference here, this is somewhere close to 2 lakh, somewhere close to 8 lakh, that is the difference. So clearly the least value still continues as social security, so we can obviously discard this. We have just find out the least. Let compare for the canteen one. Canteen one has been risen from 13.8% of 10 lakh to the next value is 15.8% of 103.2 lakhs. So clearly we can approximate 13.8% of 10 lakh as 1.3 lakhs only, that is 13% of 10 lakh only. And the next increase value is 15.8% of 100 lakhs. So this can be assumed as 15 lakhs only. So 1.3 lakh to 15 lakh, this is somewhere close to 13 lakhs. So this is obviously on the very high side. So clearly by now, by comparing these small elements, we can clearly say that the least rise has come for the area called as social security and entertainment. So that should become the right answer only. Social security and insurance has got the least increased from 86 to 96. Now, for the same pie chart, we have to answer a different question. By what factor did the allocation for recreation and entertainment increase from 1986 to 1996? By what factor it increased? Okay. So clearly, we have to see the category of entertainment and recreation. Entertainment and recreation at the 1986 value is recreation and entertainment can be seen as 35.5%. So 35.5% of 10 lakh approximately, and it has risen to 45 45.2% of 103.2 lakh, which can be taken approximately as 100 lakh. So what is the rise in value that we have to see? Okay, and by what factor, by what should we multiply it with so that it becomes the next value? This is what is by what factor. We don't have to see it in percentage. So 35.5% of 10 lakh is somewhere close to 3.5 lakhs, and 45.2% of 100 lakh is somewhere close to 45 lakhs. So now we have to see 3.5 lakhs gets multiplied by what factor so that it becomes 45 lakh. That factor should be as an answer. Okay, so we can find it out by 45 divided by 3.5. If we do this, this is somewhere close to approximately close to the value called as 13. Okay, this is approximately close to the value called as 13. So that should become the right answer only, option number B. Now, Now we have a different pie chart for solving a different question. Now what is the question? In the question they say study the graph and answer the given question. The data is about World Bank's 97-98 plan for developing nations 20 countries selected by the World Bank. So these are the 20 countries name given for which the World Bank will be giving loan to develop their countries. Okay, and there is another pie chart given beneath that which says 8 countries selected for development loan. For development loan, these are the countries selected, and for supporting loan, these are the countries selected. And the plan is also given, not the complete plan is given. For the very first data, only 92% of the plan is given, so 8% is hidden. For the second data, only 84% distribution has been given, and for the third data, only 93% has been given, not the complete one. So this is the pie chart given to us. Let us go for the question. He's saying if D was the allocated amount for development loan for this year. So development loan are these ones. Okay, so the total amount he says is D. The total amount is he says is D. Okay, for this year, assuming that each of the 8 countries listed receive the same amount of money. So out of D, each one will be receiving same amount. What would have been the amount of loan for India? Okay, so these are the 8 countries: 1, 2, 3, 4, 5, 6, 7, 8, and India is amongst them. So total amount is D, but if you see the pie chart, only 84% has been distributed. So clearly 84% of D will be distributed among these 8 countries equally. Okay, so India will be getting 84. India will be getting, as there are 8 countries and equal has to be the distribution. So 1/8 of the 84% of D. That should be the value of India that he should achieve. That 1/8 of 80% of D. That's what we are supposed to calculate. So it clearly becomes 1/8 of 84 by 100 of D. If we solve this, we can cut down few numbers. So 4 can cut this, 21, and then this is 25. So 21 by 200. This is somewhere close to 21 by 200 into D, which is nothing but 0.105 D precisely. So that should be the right answer. 0.105D is the right answer. Now for the same Now, for the same pie charts, we have got a different question. What is that question? According to the data furnished, what percent of the proposed economic assistance would India receive during the year 97-98? Okay, what percent of the proposed economic India will be receiving? What percent of the economic assistance during the year 97-1998? So that's what we are supposed to answer. Now let us see how much percent India is going to receive. Okay, so the clearly 92% of total World Bank has been given, but there is a problem that they say there is no indication as to individual distribution of the allocated aid. How much should be given to in each person, that has not been given. They say India should be receiving how much percent of the total allocation, but there is no indication that out of these 8 countries, which country has got how much percent. That distribution is not given. So it is not possible to determine if either they should mention that each country is receiving the same percentage, but they have not stated like that. They have just said that what should be the percentage received by India. So as the percentage value is not given and the percentage chart is not there, so clearly this answer of this question is cannot be determined because the data is not sufficient. That is the right answer. Now, they say for the same pie chart, the question is if 72% of the supporting assistance was proposed to India. Okay, so supporting assistance chart is this. So they're saying 72% of the supporting assistance was proposed to India, and other 4 major recipients received the same amount, each under the program of the World Bank. What percent of the entire amount would Peru have received? Okay, so what they are saying, uh, 72% of the supporting assistance was proposed to India. So whatever was the supporting assistance, let's say the supporting assistance was SA, that's 93% plan is only exposed by this chart. So the 93% of the supporting assistance is this value. They are saying 72% of this to be received by India. They are saying India should receive 72% of this amount, and the other 4 major recipients should receive same amount. Okay, so the whatever is the leftover part, that should be distributed between the other recipient equally. So for that we need to find out what is the 72% of the 93% of the total sum of the supporting assistance. Okay, so what is 73% of the 93%? That's what we are supposed to calculate. 73% of the 93%, if we do, that comes out to be 21% of supporting assistance. So that's 21% of supporting assistance has come in the favor of 4 major countries. Okay, rest has been taken up by India. That rest has been given to India rather. So now the next four, now the remaining 4 countries, the remaining 4 major components are supposed to distribute this 21% equally, as they say, same amount. Okay, so each would have received simply 21 by 4%, that is clearly 5.25%. So each country would be receiving 5.25%. That becomes the right answer. Now, now we have got a different pie chart, and we are supposed to solve the question by seeing this particular pie chart. Let us see the pie chart first. ABC company fund status on a particular date. So there is a fund given here, 10,80,192. This is the rupees of total asset. These have been distributed in terms of these 3 pie charts. Okay, what we can understand this, that first column is other asset, second sector is new investment, and the distribution of new investment is given in this pie chart. Okay, in the first pie chart there is a sector called as new investment, which is this, and the internal distribution of new investment has been given in this particular pie chart. Now in this particular pie chart you can see there is stocks, there is business expansion, there is real asset, and there is business expansion, and there is a thing called as stock which has got 56%, and the internal stock structure of these 56% have been given in this pie chart. Internal expenditure of the new investment has been given in this pie chart, and internal of stock has been given in this very pie chart. So we are supposed to answer the things like this, okay, by understanding the pie chart clearly. Now the first question is that according to the above pie chart, how much amount of money belonging to the total asset was invested in bonds approximately? So we are supposed to find out where are the bond value. The bond value is here. So bond value is 8.9%. So if we approximate this to be 9%, so clearly we are supposed to find out the 9% of 10,80,192 rupees. Okay, because the bond value is 8.9%, we approximate that to be 9%. So clearly we are supposed to find out 9% of 10,80,192 rupees. Okay, and as he said, it is approximated, so let us assume as this to be 10 lakh. Okay, which is far higher than the 10 lakh, which is close to 11 lakh only, but let us assume it to be 10 lakh. Okay, and if we solve this for 10 lakh, so what is 9% of 10 lakh? Clearly the 9% of 10 lakh is nothing but 9 into 10 lakh divided by 100, which is nothing but somewhere close to 1 lakh rupees. Okay, and this 1 lakh rupees is obviously lower value because we have approximated 10 lakh 80,000 to just 10 lakh. So obviously the value received will be somewhere close to 1 lakh only, as much close as possible. Okay, not very much lesser. So this is nothing but 95,000 rupees, which is option A. 95,000 rupees becomes the right answer. Now, for the same pie chart, set of pie chart, we have given a question. The question is, how much amount of total asset was budgeted for business expansion? Let us see where all we have got business expansion. We have got business expansion here, which is 26% in this pie chart. And this pie chart belongs to new investment profile. New investment profile in the first pie chart is this. So the correction becomes the from the very first pie chart, 48.3% is new investment. Out of those 48.3 new investment, 56% has been given to stocks, and so on, 26% for business expansion, and so on. So clearly the business expansion would be receiving 26% of new investment. This is the first thing. Okay, where your new investment itself is, if you refer the first pie chart, new investment itself is 48.3% of 10 lakh 80,192 rupees. Okay, business expansion is 26% of new investment. New investment is 48.3% of 10 lakh. So clearly, if we combine these two statements, that business expansion becomes 26% of 48.3% of rupees 10 lakh 80,192. If we combine this, this is what is the expansion becomes. And clearly we are supposed to answer in an approximated way. Okay, because we will not be having that much time so that we can solve each and everything. So let us approximate this 26 as simply 25%, which is 1/4. So this is 1/4 into, let us approximate this 48.3% to be 50%. So 50 by 100 is 1/2 into, let us approximate the 10 lakh 80,000 to be simply 10 lakh rupees. So clearly we are supposed to find out 10 lakh divided by 8, and 10 lakh divided by 8 is somewhere close to 12.5 rupees, 12.5 thousand rupees. Okay, rather 1.25 lakh rupees. So let us see where is the 1.25 lakh rupees approximation available. Yes, it is available in option number B, 1.25 lakh exactly. So that is the right answer, 1.25 lakh rupees, option B. Okay, for the same pie chart, we have given a different question. He's saying, which of the following will be greatest? Okay, so we are supposed to compare them. Which of the following will be greatest? Let us go by option. The first option is amount of money invested in stocks which yielded between 7 to 9%. So we are supposed to find over that. 7 to 9% is 65%. 65% of the stock value. The stock value itself is 56%. 56% of new investment, and new investment is itself is 48.3%. So the first amount becomes 10 lakh rupees. If we have to go into the new investment profile first, so new investment profile is 48.3%. So 48.3% multiplied by, from the new investment we have to enter into stock, and stock value is 56%, so it becomes 56%. From the stock we have to enter for 7 to 9%, that is 65% of it, so it becomes 65%. So this can be approximately written as, 10 lakh into 50 by 100 by 100, 50 by 100 into 56%, that is 55 by 100 into 65 by 100. This can be approximated written like this. And obviously we are supposed to compare. So we're not going to solve this completely. We'll try to compare it by just seeing the numbers and the expression itself. For the second one, amount invested in stocks which yielded over 9%. So 9 to 11 is 20, and 11 to over 11 is 15. So over 19, over 9 will be the 20 and 15 both. That is 20 plus 15, that is nothing but 35%. 35% will be the over 9%. Okay. So now the for this particular category, what it becomes 10 lakhs. For again, for coming to this particular stock performance, we have to come by new investment. So new investment is simply approximately 50% of the total, and from the new investment we have to come down to stock value. Stock value is somewhere close to 55%. From stock exchange, from stock performance, we have to give 35%, so into 35 by 100. This is the next set of value. And if we compare, see which of the following will be greatest. So if we compare these two, obviously the higher value is this, because here the numbers are higher. 50 and 50 is same, 55 55 same, but this is 65 and this is 35. So obviously the first option will give you the higher value. So obviously the second option is discarded. So this very option is discarded. This is coming high for now. The amount of money invested in real assets. Real assets are, where are the real assets? Real assets are given here, which is real asset value is clearly our 18%. So 18% of whom? 18% of new investment. New investment, which is itself 48%, 48.3% of 10 lakh. So the real estate becomes 10 lakhs, approximately 50%, and that 50% real estate value is 18%. So this is the value of real estate. If we compare this with our higher one, clearly the higher one is still higher, because the number here are 50 and 18 only, then the number are 50, 56 and 65 also. So clearly this value is also discarded in comparison to the first one. Let us see the next option. The next option is business expansion. If you see business expansion can be found out here. 26 business expansion is 26% of new investment. New investment itself is 48.3%. So the value becomes how much? The value becomes 10 lakh rupees. 50% approximately is that values. Business expansion was 26%, was 26 by 100. So if we compare this with the first one, again the first one becomes higher, because there are more numbers and higher numbers. So this again get discarded. Amount of money invested in bonds. What is the amount of money invested in bond? Bond value is 8.9% of 10 lakh rupees. So if you see this, 10 lakh rupees, 8.9% by 100. So clearly this is again seems to be shorter one from the first one. So clearly the amount invested for the first one is very high, and that becomes our right answer. Option number A is the right answer for us. Now, for the same set of pie chart, we have got a different question. Which of the following will amount to the least of money earned out of the total asset of rupees 10 lakh 80,192? So clearly out of these options available, we have to answer the least one. Okay. So we are supposed to see the options first. Which of the following will amount to the least money earned? But there is a problem. What they have said, amount of the least money earned, but the data is not given for the earned one. Data is just the distribution of rupees 10 lakh 80,192 in the different components. It is just the distribution and the investment part. The earning is not given. Okay. The distribution of earning or any indication of earning is nowhere mentioned in the whole pie chart. So clearly when you are asking for the earning, we will not be able to answer this. So the option becomes cannot be determined from the information given, because there is no indication or no detail of the earning provided in the given pie chart. So that becomes the right answer, cannot be determined. Okay, so there is a pie chart given, and in that pie chart, the pie chart depicts what? Let us see the pie chart and study it. Okay, so there is a pie chart in which there is A, B, C, and D sectors given. A has been provided 49%, B 39.5%, C is provided as 11%. So we are supposed to find out the D is not provided anything. So D can be found out by subtracting all the sum of A, B, C from 100%, because total value is always 100%. So that we can find out later on if it is asked. Then the meaning of A, B, C, D have been defined. The meaning of A is cost of equipment and land, B is cost of technology, C is cost of raw materials, and D is cost of training. Okay, these all values are given. Now we need to see the question. This question says above pie chart shows the total cost of re-engineering is rupees 128.3 lakhs. So the total value of the pie chart, total value of the whole pie chart, that is the 100% value, is actually rupees 128.3 lakh rupees. Okay, that is the total 100% of this pie chart depicts. Now the question is, if the total cost of re-engineering is 128.3 lakh rupees, find the value of D. So we are supposed to find the value of D. For that, first of all, we need to find out the percentage what is equivalent to D. How we can find it out? As percentage of D equivalent to D will be 100 minus, because the total percentage is always 100 minus sum of percentage of A plus sum of percentage of B, that is 39.5%, plus sum of percentage of C, that is 11%. Okay, so this is how we can find it out. If we solve this further, this comes out to be 100 minus 49 plus 11. 49 plus 11 is 60. 60 plus 39.5 is 99.5%. If we subtract, this is becoming equal to 0.5%. So the D component is actually equal to 0.5%. Okay, now they want us to find out the value of D. So value of D is nothing but 0.5% of 0.5% of the whole cost. The whole cost is 128.3 lakh rupees. So we are supposed to find out 0.5%. That will be 0.5 into 128.3 divided by 100. Okay, if we solve this out further, this is coming exactly equal to rupees 0.6 lakh, and that is approximate value 0.6 something. There are some digits further available. So the exact value is, if we go by the exact value, the exact value is 0.641 5. This is the exact value which can be approximated as 0.6 lakh. That is available in the option also, 0.6 lakh. That becomes the answer, option number B. Now, in the next question, the same pie chart is being used. He is asking that find the total cost of re-engineering. If the total cost of re-engineering is doubled, what will be the value of D? So if you study the pie chart, what happens in a pie chart is, okay, if this is a pie chart, then and it has been divided into certain sectors. Okay, if there is a pie chart and it has been divided into certain sectors like that, and value of this is, let's say, 20, value of this is, let's say, 60, and value of this is also 20, then if the total value of everything is, let's say, 20, 200, the total value equivalent to 100% is, let's say, 200, and if this 200 is also doubled as 400, so value of each component also get doubled. Okay, if the total value is doubled from 200 to 400, then value of each component also get doubled. It's not the percentage one, it's the actual real value. So value of each component will get doubled. So this will become 40, this will become 40, and this will become 120. So the value will be double. Percentage will remain same, but the value will be doubled. So according to this concept, he's saying if the total cost of re-engineering is doubled, what will the value of D? So what was the earlier value of D? We calculated in the last question. The value of D came out to be 0.6413. This was the approximate value. This was the exact value of the value of D. So the new value in this pie chart will be obviously double of it. New D will be twice of the old D. So if you do the twice of this, this is going to be 0.6413 into 2, which is close to 1.28 or approximately equal to 1.3 lakhs. So that is the final value, 1.3 lakhs. Okay, that is available in option number B, becomes the right answer. Now, for the same pie chart, we are supposed to solve if there is 4 times increase in the cost of technology, what will be the total amount spent for hiring the new technology? So cost, if there is 4 times increase, so let us understand what is 4 time increase. Okay, how we can find out 4 time increase? Okay, 4 time increase can be found out by, see, suppose there is a value whose value is 100. If 100 increases 4 times, okay, if 100 increases 4 times, it actually becomes 400. Okay, so how much is the increase? Increase is actually, the increase value is 400 minus 100, that is 300. Okay, so whenever a thing becomes 4 times of itself, the increase is actually 3 times. Okay, the increase is always 3 times or 300%. In percentage it is 300%, and in the terms of times it is 3 times. Okay, so if there is a 4 times increase in the cost of technology, what will the total amount spent for hiring the new technology? Okay, so let us find out what is the value. By now 4 times increase is there. So what is the cost of technology right now? Cost of technology, as mentioned, is 39.5%. That is B value. B value is quoted as 39.5%. So this is the cost of technology. So we are supposed to find out the 39.5% of the total value. So total cost of technology becomes how much? before the increase. This we are calculating before the increase. Total cost of the technology becomes how much? 39.5% of the total cost, that is 128.3 lakh rupees. If we calculate this further, this is 39.5 over 100 into 128.3. If we solve this, this is coming exactly equal to 50.7 lakh rupees. 50.7 lakh rupees. Okay, this is the value coming. Now they say there's a 4-time increase. As we proved it that there's a 4-time increase, so clearly the value becomes 4 times of the older value. So if you do the 4 times of the older value, we can easily find out. So 4 times of 50.7 lakh becomes simply 202.8 lakh. So that is the final answer, 202.8 lakh rupees. That is the value of what is being asked. What will the total amount spent? Total amount spent will be simply 4 times of it. Okay. If they would have asked how much increased amount would have been spent, then we would have done 3 times. They are sending find the total amount, increased amount, so that has to be 4 times itself. Okay, the next question is total cost increases by 5 times. What will be the increase in the percentage? So if anything increases 5 times, the percentage increase is always 4%. For example, if 100 becomes 5 times of itself, that means it becomes 500. How much is the increase? Increase is only 400. And because it is the case of 100 only, so in percentage increase is also, the percentage increase is also 400%. 100 becomes 500 by increasing by 400%. So percentage increase is 400%. So whenever things become 5 times of itself, the percentage increase is always 400%. So that becomes the right answer. We don't need to solve this for anything. Questions number 73's answer is option number B, 400%. Now, for the same pie chart, the question is the cost of training increases from zero point 0.6 to 2.4 lakhs. What will be the percentage increase? So clearly a value is increasing from zero point 0.6 to 2.4 lakh. So what is the percentage increase? As we discussed in the last question, that whenever a value increases from 100 to its 4 times, that is 400, so the increase of 300% occurs. 400 minus 100 is 300%. So if the value, what has happened here? Value has increased from 0.6 to 2.4 lakhs. That is nothing but 4 times again. So whenever the value becomes 4 times of itself, the percentage increase will be 3 times. Okay, so the percentage increase will be 3 times, or the percentage increase will be simply 300%. So that becomes the right answer. Percentage increase is 300%. Option C is the right one. Now, the cost of technology increases by 2%. How much amount will be involved in buying the technology? Okay, cost of technology increases by 2%. So let us see the cost of technology. Cost of technology was B, that is 39.5%. We have already calculated it in the last question. Let us find out that 39. Let us solve it again. 128.3, that is the total value, and 39.5% of it, that will be the value of cost of technology, that is B. 39.5% of this, and if we had already solved in the last question, that is 50.7 lakh rupees. Now he says the cost of technology increases by 2%. So how much amount will be involved in buying the technology? So clearly the amount involved will be 2% more than 50.7 lakh. So we have to find out the amount involved. Amount involved will be obviously 50.7 lakh plus 2% of 50.7 lakh. This is what we have to calculate. Okay, so this can be calculated by 50.7 lakh into directly 102% of 50.7 lakh, and that value comes out to be precisely that comes out to be approximately that comes out to be 52 lakh rupees. That is coming somewhat 51 point something something, and that can be estimated as 52 lakh rupees approximately becomes the right answer, option number B. Now, for the same pie chart, we are supposed to find out cost of technology and cost of equipment and land put together will amount to. So cost of technology we had already calculated, that was 50.7 in the earlier question. That was calculated simply by finding out the 39.5%. So 128.3 into 39.5%. This is how we calculated this 50.7 in the earlier two questions itself. Now this is the cost of technology. The next thing is to be added as cost of equipment and land put together. Cost of equipment and land is 11%. So clearly we are supposed to find out 128.3 into 11 by 100. Okay, if we calculate this coming out to be 128.3 into 11 cost of equipment and land, that's what we are supposed to find out. So 128.3 into 11 upon 100, that's what we are supposed to calculate. This is somewhere close to 11. So we can obviously approximate this 128.3 into so 10% of 128.3 will be somewhere close to 12.83 lakhs. So 11% can be somewhere close to 13 or 14 lakhs. So we can obviously add this together. So let us take this as 12 lakh only. So earlier the value, the first value is 50.7, this value is 12 lakh. If we add, this is somewhere close to 60.7 lakh. Okay, that is somewhere close to 60.7 lakh. Okay, 50.7 and 12.8. Okay, these are the two values that we're getting. 60, rather 62.7 and 50.7, these are the two values, 60.7 and 50.7. If we add them together, this is somewhere becoming close to 112.7. that is nothing but approximately equal to 113 lakh rupees. Okay, 113 lakh rupees. Let us see where it is available. It is available in option number C and becomes the right answer. Now, we have a different graph. This is a bar graph, and we have to study this bar graph. Then only we can answer the question as associated with it. Let us study the bar graph. The bar graphs, the idea of the bar graph and the title of the bar graph is here. Number of female voters has increased sharply in the 7 states since 1973. Okay, the white line indicates the year 1973. The gray color indicates the today's. Okay, that today could be whatever is the date taken, whatever is the year taken, but the today value is represented by gray color, and 1973 values are represented in white colors. So if we want to study this for the state called Punjab, 163 is the amount of white color. So unit of this is must be given somewhere. They say number of women voter has increased sharply in the 1970. So clearly the unit is as stated itself. So in Punjab, we can study this. In Punjab, in the year 1973, the female voters were 163, and in the same Punjab today, the female voter becomes 313, and so on. We can read for all the states as provided. So let us go for the question. Which state had the greatest increase in the number of female voters? So clearly we need to find out the increase value. Okay, so we for the state called as Punjab, the increase can be found out by 313 minus 163. Okay, for the state called as Bihar, the increase can be found out by 281 minus 33. For the state called as Maharashtra, the increase can be found out by 295, the gray color minus the white color as 113, and so on. We can find out the increase for each and every year by subtracting. And by subtracting, we can observe that the greatest increase has been found out for the state called as Bihar, because 281 minus 33 is the highest difference. So the right answer becomes clearly Bihar. We don't need to calculate this also. We can get a little idea out of it that 281 minus 33 is the highest value. So that becomes the right answer. Option number D, Bihar. Now, for the same bar graph, we have to suppose to answer the different question. The question is, in which state was the number of female voters almost doubled? So let us see, let us study in which particular state is happening, the voters getting double. In Punjab, 163 becomes clearly 313. So this is itself is becoming doubled. Okay, this is approximately double, because double of 163 is somewhat close to 326, and we are already getting 313. So this should be taken in the consideration that for the state called as Punjab, maybe the things getting doubled. Let us check other option as well. We have got other option as Bihar. So in Bihar, 33 becomes 281. That is not possible that it is doubled. In Haryana, the value becomes 245, and it becomes 296. So that is also not doubled. West Bengal, the value is 254 and it becomes 370. That is also not doubled. And for Maharashtra as well, you can see the value is 113 and that has become 295. So that is way more than double. So clearly the double is happening only in the state of Bihar. So that becomes the right answer, option number B. Rather, the things are getting doubled for the state called as Punjab, not Bihar. So Punjab is the right answer. Okay. About what percent was the number of female voters in Bihar in 1973 as compared to the number today? So what they're asking, female voters in Bihar in 1973 was at what percent as compared to number today? So let us see the female voter in 1973 in Bihar. The female voter value, let us see that. So in Bihar, you can see the 1973, the value is given as 33. And in the same state called as Bihar, today value we can read from the graph. Today value is 281 for the state called as Bihar. These are the data available, 281. We are supposed to find out the percentage of Bihar in 1973 with respect to the percentage in Bihar today. So that has the percentage can be calculated by 33 divided by 281 into 100%. Okay, this is how we are supposed to find out the percentage. Okay, 33 out of 281. So we can obviously approximate this also, and we can guess the right answer also. So this is, if we solve this exactly, this is somewhere close to 1 by 8%. That is nothing but that is 100 by 8%. That is nothing but 12.5%. Approximately, it is coming out to be 12.5%. Okay, so let us see among the option. Okay, they are asking for the percentage value, and if you see the option number D states 12.5%. So that becomes the right answer. Now, for the same bar graph, there is a question provided. What was the total number of female voters in those 7 states in 1973? He's asking what was the total in 1973 for all the states. So clearly, we are supposed to add the values in white color for all the states. So we have to add like 163 plus 33 plus 113 plus 254 plus 143 plus 245 plus 169, and the total of this will be our answer. So we have done already the total for that, and the total comes out to be 1122,000. Okay, 1122,000, that becomes the value, and that is available in the option as option number A. So this is the right answer. Now the bar graph is there, and we are supposed to answer the questions like, according to the chart, which state has the largest number of female voters at present? So this can be obviously observed, and we don't need to calculate anything. So whichever has got the highest bar in the picture, that will be the largest number of female voters at present. So at present means today, so we have to see the gray graphs, and whichever is the highest, that is our answer. So it is highest for the state called as West Bengal. So that becomes the right answer. Option number C becomes the right answer. Now, we have got a different bar graph this time, and we are supposed to solve it. Let us understand the bar graph first. Indian fabric production. So, fabric production by India has been provided. The value varies from 0.8, 2, 4, 6, 8, and so on. And the unit must be also there. Okay, and the billion square feet, so this is the value, billion square feet. So if it is written as 0.8, the value is 0.8 billion square feet. If it is written 2, the value is 2 billion square feet, and so on the y-axis, the years are provided from 1986 to 1997. This is how the year wise Indian fiber production in terms of billion square feet has been provided as the data. Let us see the questions. What was the ratio of Indian fabric produced in 1986 as compared to 1995? So let us pick the data value, 86 value. Okay, for the year 1986, the value is somewhere between 6 and 8. So obviously we'll have to approximate something. Okay, let us approximate this as 6.4 for the year 1986. And for the year 1995, let us see the value. The chart is here. So for the 1995, it is between 12 and 14. Let us approximate this to be 12.8. If we simplify this ratio, this has to be 6.4 is to 12.8. So this is nothing but 64 is to 128, which is close to 1 by 2. So the ratio becomes simply 1 is to 2. So that is the right answer available in option number C. Now, for the same bar graph, we have got a different question. The question says for the years 1986 through 1991, 86 to 91, excluding 1990. So we have to separate. We have to exclude 1990. How many billion square feet of fabric were produced altogether? So clearly, we are supposed to add the data for 86, 87, 88, 89. 90 is not included, so 91. So we have to add these all values, and that should be our answer only simply. So let us add these values. So the values are 6.4 plus 7.8. We are obviously approximating when the values are in between by seeing the growth of that particular bar. 7.8 plus 7.9 plus 8.4 plus 10.2. Okay, if we add them together, this is coming out to be approximately 40.7. Let us see where it is available in the options. It in the option is provided as 40.7, option number D. That becomes the right answer. Now, there is a bar graph. The same bar graph is there. This time around, we are supposed to answer between which consecutive odd years and between which consecutive even years was the Indian fabric production jump the greatest. So we have to compare consecutive odd years also and consecutive even years also. So for this, we'll go by the options. Let us see the option. First option is 93, 95 and 86, 88. Let us see the values. 93, 95. So the value for 1993 was this, and this can be approximated somewhere around 12.5. And for 1995, how much is it was for 1995? It was between 12 and 14 again. So let us approximate this to be 12, 13. Let us approximate this to be for the year 1995. This is approximate. This is very much close to 14. So let us approximate this to be 13. So if we add them together, this is coming out somewhere around 25.5. This is happening for the year 93 and 95, and this is for the odd time. Let's see for the even time. We are exploring option number A, 86 and 88. So 86 value is very low. This is somewhere between 6 and 8. So let us assume it to be 7 plus 90, 88. 88 value is this. Okay, 88 value is somewhere is again between 6 and 8 and very close to 8. So let us assume it to be 7.5. So become something around 14.5. And this is how we are supposed to check 26.5, 25.5 and 14.5 for the option A. We can check this for option B also, for both the set or consecutive odd and consecutive even, for C also consecutive odd and consecutive even, and for D also, and so on. We can keep on checking. If we check these values, we can see between 91, if you see the 91 to 93, okay, 91 to 93, the value has been from 10.3 to approximately 12.4. As by the by the graph you can see, between 91 and 93 it has gone from 10.3 to 12.4, which is approximately 12.1 million square feet. Okay, 12.1 billion square feet. And if you see the jump from 90 to 92, the jump from 90 to 92 has been from 9.2 to 11.4. The jump is 9.2 to 11.4, which is somewhere close to 2.2 billion square feet. Okay, 2.2 billion square feet. Okay, and if you this has to be the highest growth. 12.1 in the odd and 2.2 in the even. This is seems to be the highest growth among all the options. So that is the right choice only. Option called as D is the right answer. Okay, option called as E rather is the right answer. 91 to 93 the jump, and 90 to 92 the jump. That is the highest jump. Okay, now, we have got a different bar graph now. Let us study the bar graph first, and then only we are supposed to answer the question. The bar graph states, let us try to understand bar graph. The title of the bar graph is Disability Beneficiaries Reported as Rehabilitated Number as Percentage of All Rehabilitated Clients of the Central Rehabilitation Society. The data is from year 1980 to 1996. So clearly, each bar graph represents a particular data. And what is that particular data? For example, for the case of 1980 to 90, the percentage value of 1.9% is given, and the total value is somewhere close to 15, between 15 and 20. So we can assume it to be 18. So what is the data represent? That 1.9% of the total 18,000, because the numbers are in thousand, 1.9% of the total 18 or 19,000 disability beneficiaries have been rehabilitated in that year, in that particular span. Now, similarly, what does this 4.4% represent in the year 1991? That out of total, the total value here is just above 5 and lesser than, very much lesser than 10. So let us take this as somewhere around 7. So out of the total 7,000 disability beneficiaries reported, 4.4% of that have been rehabilitated. This is how the data is provided. So let us see the questions and try to solve them. The first one is between 1992 and 1996, the largest number of disabilities beneficiary were reported as rehabilitated in the year. Okay, for which year? Between 92 and 96, that there is a largest number of rehabilitation happened. Okay, so clearly we are supposed to see the data for between 92 and 96. Okay, so 92 is this and 96 is this. We have to read the data between this only. So clearly for the 1992, this is somewhere close to okay, this is somewhere close to 3.9% of 7 lakh. Okay, 7,000 rather. This is for the year 1992. If we see for the year 1993, it is somewhere between 10 and 15. So let us approximate this to be, if it is 10 and 15, let us approximate this to be 12.5. So for the year 1993, uh, we are supposed to find out for 1993 6.2% of 10 and 15. So it has to be 12.5. Okay, 6.2% or 12.5. For the year 1994, we are supposed to see the value is very high. So the value is somewhere close to 17. So, how much is the percentage value in the year 1994? It's 6.6%. So, we have to find out 6.6% of 17. That will be in the year 1994. If we go for 1995, the value is way higher. That is more than 17. So, let us take it as 18. So, 18% of the rather 18 is the total value. How much is the percentage value in 1995? Is 6.5%. So, it has to be 6.5% of 18 and so on. For the year 1996, how much it is? The value increases further. This is more than 18, so let us take it as 19. So how much is the percentage value? Again 6.5. So 6.5% of 19 again. So we are supposed to see these datas and find out which is the highest value. So by observing the data, 3.9% of 7 will be very much less, 6.2% of 12.5 will be very less, 6.6% of 17 will be very much less. So obviously the data should be somewhere, the highest value should be somewhere between 6.5% of 18 and 6.5% of 19. And clearly the highest value will be 6.5% of 19 only. So the year called as 96 is our right answer, which has reported the largest number of disability beneficiary as rehabilitated. So option number E becomes the right answer, 1996. Now, for the same data, we are supposed to answer a different question between 1980 and 90. About how many clients were rehabilitated by central rehabilitation societies. Okay, so in the year 80 to 90, if you see the data, the total value is, if you see the total value, that is somewhere between 15 and 20. So let us approximate this to be 19. Okay, can approximate this to any value so that we are somewhere in the reach of the options only. So let us approximate this to be 19,000. Obviously the unit is 1000. Okay, and how much is the percentage value? 1.9%. So rehabilitated people would have been simply 1.9% of 19,000. Okay, if we calculate this further, this comes out to be 1.9 into 19 over 100. This is how it can be calculated. 1.9% of 19,000 people have been rehabilitated, and if we calculate this further, this comes out to be somewhere 10 lakh 10 lakh people. Okay, so that should be the right answer. And obviously that is approximated value because we have no indication between 15 and 20 that what are these value means. That's why we have approximate the value to be 19 so that the calculation becomes easy with respect to 1.9. So answer becomes 10 lakh. Let us see, it is available where? It is available in the option number C directly, so becomes the right answer. Okay, now we are provided with a bar chart. We are supposed to see the bar chart and then we are supposed to answer. Let us study the bar chart first. The question says distribution of 3,02,000 degree holders according to the age of the students in 1995. In the year 1995, what they have provided is the number of graduate holders for different age groups that which have taken their degrees. Okay, so we can understand this as for the age group between 18 to 21, the value is somewhere close to 11. So that means 11,000 people of the age of 18 to 21 have been graduated in the year 1995. Next bar set is 21 to 24. The highest value, the 21 to 24 bar graph touches somewhere 61. So we can write this as between 21, the age group of 21 to 24 years. Out of the age group of 21 to 24 years, there have been 61,000 people of the age group of 21 to 24 who have got graduation in the year 1995, and so on. We can read this data till the age of 66 to 69 bar graph also. Okay, now let us read the question. Approximately what percent of the student who graduated were of the age between 21 to 27? So we are supposed to find out. First, let us see what is the number of people who graduated of the age of 21 to 27. Okay, so that can be studied from the graph itself. 21 to 24. So clearly, we are supposed to add two values, 21 to 24 plus 24 to 27. We are supposed to add the number of these age groups, 21 to 24. If we see between 21 to 24, the and add it together, 21 to 24 number is somewhat 61,000, and between 24 to 27 it is somewhere close to 73,000. Obviously we are approximating things because the clear Picture is not depicted, the scales are not provided, so we are supposed to approximate. So 61,000 and 73,000. So the total becomes how much? The total becomes 1,34,000. So this is the total number of people who have graduated of the age group of 21 to 27. What they are asking, what percent of the total students? This value is what percent of the total student who have graduated. So clearly we are supposed to find out 1,34,000 is what percent of the total people who graduated, that is 3,02,000 people. So 1,34,000 is what percent of 3,02,000. Whatever appear after of becomes the denominator. So the denominator becomes 3,02,000 into 100%. So this is how we can solve this. Okay, if we calculate this further, the zeros are obviously gone, so we are left out with 134 over 302 into 100%. Okay, if we solve this, then this is approximately equal to 44 by 100. If we have just cut, if we have approximated 302 as 300, so we can cut down the numbers by 4, so by 3, so the number are coming 44 by 100, and into 100% is also there, so it clearly becomes 44%. So that becomes the right answer. 44%, which is available in option number D, becomes the right answer. Now then he says, for the same bar graph, he says, in this group, the number of students who graduated at the age 36 to 39 is probably about what value? So 36 to 39, we have to see 36 to 39. This is that graph 36 to 39. And obviously, we are supposed to approximate the value only. So if we see the values 36 to 39, it is somewhere between 10 and 20 and very much close to 20. So we can approximate this. So we can guess it like that the number should be somewhere between 10 and 20. So let us explore the options. Number should be somewhere between 10 and 20,000 only. So the only number that is in the range of 10 to 20,000 is 14,000. So that's how it becomes the right answer. Now, the same bar graph, we are supposed to answer a different question. Question is, in 1 million degree holders, how many thousand to the nearest thousand students would you expect to be between the age of 51 and 60? What they are saying, if this total the total number of student is not 3,02,000, rather it is 1 million. Okay, then he's saying, out of those 1 million, how many thousand student would you expect to be between age of 51 and 60? So clearly we have to find out the percentage of 51 to 60 from this first, or rather we can do it by a ratio method also. If we go by the bar graph, the ratio of people graduated between 51 to 60 years to the total people who graduated, if we see like that, so that number comes out to be the people between 51 to between the age of group of 51 to 60 is, let us see the graph, 51 to 60, this 51 to 54 is this, 54 to 57 is this, and 57 to 60 is this. So clearly if we add these number, this is somewhere close to, let us add them together, so this is somewhere close to 6,000 is to total value is clearly 3,02,000. Okay, so the ratio of number of people at the age of 51 to 60 to the total number of people becomes 6,000 is to 3,02,000. They say if this total becomes 1 million, so in the side of 1 million, in the side of 3,02,000, I can write it as 1 million, that is this value. Okay, 10 lakh rupees. So 10 lakh people. So 10 lakh becomes the right ratio. So what should become the left ratio? That becomes the question. Okay. Out of 1 million, how many will be at the age group of 51 to 60? So clearly we can solve this by the application of ratios. How we can write 6,000 divided by 3,02,000 is holding what ratio with X is to 1 billion, 1 million. Okay, this is how I'm supposed to solve this. So we can cut down the zeros like that. So 3 zeros are gone here. 6 divided by 302, okay, holds what connection with 1 million? Okay, so clearly we can solve for X. So let us approximate this 300 to be 300 only, so that the things become easy for us. So this cuts, 6 cuts the 300 by 50. So X becomes clearly 1 million divided by 5, and which comes out to be somewhere close to 20. okay, which is approximately somewhere close to 20, very much close rather. So if you see the option over there, 5, 15, 16, 17, so the most close to the word to the number 20 is the value called as 17. So clearly that becomes the right answer. The 17,000 people will be nearly there who will be at the age group of 51 to 60 if the total number is reduced to 1 million. Okay, so that becomes the right answer of the question. Now, for the same particular bar graph, we are supposed to answer the different question. Okay, the question says, which of the following best represents the percentage of students who graduated at the age of 24 or younger? So clearly he is asking, what is the percentage of people who graduated 24 or younger out of the total people who graduated? So for that, we need to first see what is that number of the age group of 24 or younger. Okay, 24 or younger. Okay, so for that we need to see how many people are there which are 24-year or younger. Okay, so for that we need to see the graph. Let us see the first for 18 to 21. Okay, for the age group of 18 to 21 approximately, so this value is higher than 10 and lesser than 20 and very much close to 10, so we can assume this to be 11,000 people. Okay, now the next age group in the same sequences, 21 to 24, we have to see till 24 or younger. So 21 to 24, if you see the values here, 21 to 24, this is the peak of the bar, and the peak of the bar is somewhere close to 60, very much close to 60, so we can assume it to be 61,000. So if we add them together, we will be getting the age group of 18 to 24, that is 24 or younger. Okay, so 11,000 plus 61,000 is 72,000. So there are 72,000 people who are at the who have been graduated and they were at the age of 18 to 24. 72,000. Now he has asked, what is which of the following best represent the percentage of student? So clearly we have to find out the percentage of the 72,000 people out of the total people who have graduated, and this has to be given in terms of percentage. So clearly 70, the question becomes 72,000 is what percent of total value, that is 3 lakh 2,000 people that has been already given, 3 lakh 2,000, and percentage value is always calculated by multiplying it by 100%. Okay, if we solve this further, we can easily cut down the zeros. So this comes out to be 72 by 302 into 100%. We can obviously approximate this, okay, to match up with the right answer. So this 302 can be approximated as 300. So it becomes 72 by 300 into 100, and 100 cuts 300 by 3, and 3 cuts 72 by 24. So the approximate value is 24, and it is available in option number C. So it becomes the right answer for us.